Hi, Danny. How's it going, sir?
It's going well, Balint. Hopefully you can hear me right now.
I can hear you. I can hear you. And I know there's a video capture card issue today, right?
Yeah, if I appear a little bit fuzzy, it's not because I forgot to shave today. It's because I did actually shave today. Um, yeah, my capture card it like squashed everything. I had to manually unsquish it, and I don't know. It seems to be in its death throes currently. So I've got a new one, hopefully showing up tomorrow morning. But
Oh,
it should be actually 4K, so it will be an improvement. So it'll be a blessing in disguise, I think.
nice. That sucks
Yeah.
though. Like especially right when you're about to go live and everything starts breaking.
Yeah, I ended up starting an hour later than I thought I would today, but that's okay. You know? Yeah.
Well, thank you so very much for taking the time as always to chat with us.
Thanks for letting me.
It's
Yeah, I appreciate the invite,
Yeah,
as
y'all.
always.
This is like one of my favorite segments of the entire week because Danny and I we picked out papers in our respective fields that we then want to talk about, and then we ask questions from each other's perspective, like either it be genetics or fossil science, and it's I
Uh
think
huh.
bringing us both an appreciation for each other's fields more so than we like. It's not like we didn't respect each other's fields, but it's like different way of thinking about the science that we do.
Definitely. I definitely feel like I have a better understanding of genetics and epigenetics, and it's always cool to have that additional perspective. It definitely makes me a better scientist than I would otherwise be, and it's in like a post-COVID world, I don't get out as much and talk to other scientists as much as I would like to. I think that's kind of this is kind of the way that the world is now, and so this is a really really nice way to do that. I feel recharged after each one of these in a cool way, and like more eager about pursuing my own research. And it's almost like that same feeling when you get when you go to a conference.
Yeah.
You're like, I'm so jazzed to do science now. It's a little bit of that every Wednesday.
And the other like great part is because I have like it's a new field, like almost of how
Uh-huh.
we're learning. Like I never would get exposed to fossil science, right? Because
Right.
it, like even on
Yeah. Yeah.
conferences, it's like that very insular, like this is genetics or neuroscience, but like this way, it's like I get a whole new perception and like a
Uh-huh.
whole new take on the science, and it's so much fun. And I can't tell you how much I enjoyed and appreciate that we do this.
it's I feel the same way, Balin. Yeah, and I think it's so cool that Twitch gives us a platform to be able to do this too, because I, yeah, I don't know. I know when I was a kid, when I was like, dreaming of becoming a paleontologist, I would love to see this kind of like I would be crazy about this, being able to see two scientists just like talk about the respective fields and ask each other, you know, what might feel like dumb questions, but it's like science can be very specialized. Like, I don't know anything about genetics, and so I might be asking you questions that might sound dumb to you as a geneticist, but like there are people in the chat who might be curious about those things too. And I don't know, I just think I really like this format. I think this is a cool way to communicate science and hopefully to humanize science a little bit too, you know?
That's what I was gonna say because there's so many of like in this ivory tower mentality of like I
Yeah.
we were talking about it during the earlier in the stream of like my last PI was like where I'm in this ivory tower and why would you do science communication because no one's gonna understand it anyway. And you know I how much does she know about sauropods?
Nothing. She probably doesn't know what a sauropod is.
Exactly. So it's like, come on, like this is we are not infallible. We don't know everything. Even in our own fields, we
No,
don't
we're
know
human
everything,
beings, just
and
like
that's
everybody else.
okay.
Yeah.
And that's
Yeah.
okay, right? Like that's actually a good thing
Yeah.
because
Yeah.
science is growing. And like, I imagine if I had been a kid and had you available as a resource, like on Twitch, how
Likewise.
how
Yeah.
cool would have that have been to learn about
Yeah.
dinosaurs from? Because like I as a kid, right? Who doesn't love dinosaurs, right? And
Exactly.
you
Yeah.
get documentaries, but you can't ask the person who's in the field telling you like what life might be like as a paleontologist, like what it
Uh huh.
takes to make it, like what you do during the summers, and like
Hmm.
what is field work like or how you told us like how you find a bone. You might walk past a bone and be like, I can now size up this bone and be like, you know what, this isn't a worthwhile dig site. We're gonna keep moving on. Like all of this like innate knowledge that you now have. That would have been so cool to have known as a kid what one has to do. Anonymous, thank you for like gifts up to Svarkin, by the way. Thank you, Anonymous.
Nice.
And so that's just like I think an amazing resource that Twitch gives us, or like Volcano Doc, right? Like, who doesn't like volcanoes? Everyone loves fire.
Yeah.
And, and she, it's so funny. She even in our chat will get questions like, "What happens if you pee in a volcano?" Right? And it's silly, but it's like a first step to get people excited.
Absolutely, and that's also like a legitimate question. It's like you could use that and you could talk about the toxic gases that volcanoes are emitting, and like if you're close enough to pee into a volcano, like you're probably too close, and like. Yeah, like they might seem like goofy questions, but you know, I'm sure she's thought about that as a scientist, you know?
Yeah, and it's like you're opening the door to other people, like because I mean I know y'all we aren't yet like on the paper, but I think this is important. Like if you ask a scientist a question, they might have like this, why would you ask this? And then you're immediately put off. Right, the person who's asking.
Yeah.
And justifiably, right? Because, like,
Uh-huh.
I wouldn't want to ask the person who's rude to me additional questions, and I might not be interested in the field, and so.
Yep. But that's the thing is that I think streaming on Twitch has been really good for both of us as scientists too, and that like we sometimes get jokey, memey questions like that, and like it's important to respond to those earnestly, and you know, use those as teachable moments. And you know, if somebody's going to try and troll you, they might roll their eyes and then, you know, close the tab and go elsewhere, and that's fine. But you get to have a cool discussion about a particular scientific topic, and hopefully it's entertaining as well because it started off with a goofy question, and you know, it's good for everybody.
And sometimes it's hard to know, right? Because there might be an instance where someone, like something that you and I might think of as goofy, it may have been in someone's education. That this is a thing, like a phenomena, and so you know you treat it as like a legit question, and then you could rabbit hole into like 10 next topics, and then that person would be like, "Wow, that's cool," and then you continue on with it. So I think you know this is why like that accessibility is so important. And
agreed.
TwitchCon this coming year, Danny. I'm telling you, we're gonna take over. Round 2.
I'm so excited about TwitchCon this year. Holy cow. I wrote out a whole list of like things that I would do differently next year when I was at this year's TwitchCon, and put all of those into practice. It's gonna be great.
I'm excited. And yeah, because you and Lordy and Ios, I think you said already like got your hotels booked and y'all like are all set to go.
Oh yeah. We're raring to go.
Nice.
It's gonna be awesome. Yeah, nice. San Diego.
In that Gaslamp district too, like it's right on the waterfront. It is such a beautiful location.
I can't remember the last time I was probably a toddler the last time I was in San Diego. Even living here in California, San Diego is like a 9-hour drive away.
Oh wow, okay.
You know? It's like, I don't know, but it would be like for you driving down to South Carolina or something.
I didn't realize it was such a long distance from you, because whenever you
California's a lot of latitudes.
Yeah,
in California.
It just feels like the Bay Area feels like it should be close also to San Diego, right? Like naively.
Oh, yeah. We're Northern California, you know. California is like the Chile of the United States. It's long and thin, and it runs down the Pacific coast.
I very much like it called the Chile of the That's amazing.
Yeah.
Oh, I'm so super excited. I hope we can meet up again and hopefully get another panel, because that would be
yeah. Let's. I think we should be a shoo-in this year.
Yeah.
Given the success of the last panel, so.
And I know you were here in chat, but I was promoting that we're with our partner party on Saturday. They let us have this like front page hero slot at 9 p.m. Pacific Standard, midnight Eastern on Saturday, and so we've got planarians, Hydra, tardigrades, living samples to look at under the microscope. We have the amber. Nice. We're gonna science the heck out of it, and hopefully, again, like the idea, y'all, and I don't just like preach this, I believe it, that a rising tide brings up all the ships of science, and hopefully like the whole
Yes.
community will lift it, and this will put science in like the big limelight. Like it's not just like a paper on screen necessarily. It's like Danny's got the 3D printed dinosaurs, the field digs. You know, we've got like the IRL streams. We've got the samples underneath the scope, and like hopefully bringing people closer to it will excite them and bring everyone closer together.
I love that. I dream of a world where we've got a bunch of different scientists streaming on Twitch, and that this becomes like a regular way to do outreach as scientists. I would love to see that happen, and you're helping make that happen, Balint. So thank you for that. This is exciting stuff.
Fingers crossed. Yeah, I'm ever so slightly nervous, but like
you're gonna do great. It's gonna be awesome.
To pull back a curtain before we get started on the papers, you know, they told us we would like it was on the 6th, right, that we got this email that you can pick your time, and the time started on the 19th of January. So that was last week.
Yeah.
And I hadn't heard what time we got. And so I reached out to a mutual staff member, a friend, not Queen Ios, someone different, that we met at the con, and I was like, hey, I'm so sorry to bother you, but do you by chance know what the deal with this is? And she was like, oh, just submit a ticket and they'll help you. Submit a ticket. They're like, we have no idea what you're talking about.
That happened with me when I was trying to float the panel idea. I didn't know there would be like a formal procedure for that, so I submitted a help ticket and like never got anywhere.
No, yeah, they're like, sorry, we don't know. And so I went back to this person. I was like, so this is what they said. Can you by chance help? And so she went and she dug it up. She found out what time slot, and she's like, I'm so sorry that when the layoffs happened a few weeks ago, the people in charge got let go. And I was like, oh god, it's like people probably have no idea if they got a time slot and win for it, but we'll be doing the science that day.
Yeah. Okay.
So I'm
shoot.
excited.
What time did you say again? I want to be able to be there for part of it.
9 p.m. Pacific is when the front page starts.
This coming Saturday?
This coming Saturday, yeah, the 27th. We'll be live before then because it's actually our partnerversary. That Saturday too, and then we're
just by sheer chance it happened to be your partnerversary.
I'm like, stuff is lining up. It's such a good day. And then tomorrow is baby Alona's birthday, and so
happy birthday to her, 1 year old.
Yeah.
Wow.
We're doing a little birthday party for her live on stream. People have been sending presents off the throne page, so we've got a pile of presents for her to open, and we're gonna be like, we're doing like science and community games, and we have an art style challenge that day, and then her birthday party too. And I'm like, how cool is it you can share like, your family and like interacting with that. And actually we were looking at old photos of her from that day, like her birthday, and there was a clip of your channel actually of you getting the news that we had the little one delivered, and how you were like put the picture up on screen and said like, even though we weren't, because I was in the delivery room, you're like, congratulations. And I have the clip of it, and I was like, oh, Danny, you remembered how cool that was.
That's wonderful. Holy cow, that warms my
heart. Y'all, I can't believe it's been a year either. Oh my goodness. Okay, I am so sorry, sir. You have to go presumably soon. You have to have dinner and like all the things.
No. My schedule's kind of wide open tonight. Ios and Lordy are off on vacation. They're out of the country right now.
Oh wow.
I got the place to myself. And I already fed the cats. We're good.
Okay.
Yeah.
All right.
Yeah.
So, what paper should we get started on? What are you feeling tonight?
Why don't we do your epigenetics and biological age paper, biological age and immune system one, because that was the one from last week.
Yes.
I'm hoping, because I didn't reread it. Okay, good.
It is.
I thought it was the same one from last week.
Yeah, I thought that it was an important enough one to dig into because it kind of applies to both of us, because of where the paper has gone like up to that point in terms of background information. And the reason I say it might apply is because it is a way to get a accurate representation of the age of an animal
Mm-hmm.
that is closer to its true age versus it being like a metric of its chronological age. So there are multiple kinds of
Right.
aging, and so
Uh-huh.
one of those kinds is this biological aging versus chronological.
Uh-huh.
And so the story, I don't know if you know that the guy who invented this clock is a really amazing story.
Mm-hmm.
Um, so he didn't have anything to do with epigenetics. He was like, I don't want anything to do with this. This is annoying, irritating. Forget about it. I don't want to be involved. And he
Uh-huh.
ended up getting a paper. Let's see, is it this one? Where he was the sole author of this paper. I think this is it. First sole author in Nature.
Uh-huh.
Like just this one author, and it's like that's what this how this
Wait,
ended up.
you mean that was his first paper?
But so like he was the only author. There was no one
Oh,
else
okay,
involved
okay,
in
got
this
you.
study. Yeah. So
I was
it
gonna
was,
say if that was his very first paper and it was a solo authorship in Nature, that would be nuts.
I mean,
But it's
hats
still really
off.
cool that that's in Nature. Like
Well,
that's a big deal.
but so
For those of you who don't know in the chat, at least in paleontology, there's two really really huge superstar scientific journals. They're called SciAnts and they're called Nature. Like those are the two huge journals, and like if you get a paper in either one of those, it almost guarantees you that you'll get a job somewhere. Like that makes you kind of a superstar. And so the fact that this guy got that is something.
and that's
Yeah.
true for like our field too, with the addition of one more journal in that cell.
So
And the
okay.
only reason paleontology doesn't have that yet is because we don't yet have an ability to
Yeah,
extract
to look at
DNA.
cells for the most part. Yeah.
Which Lita and I were actually getting into an argument about that, like, or a heated, friendly discussion. She was
Uh huh.
suggesting that there's no reason to think that eventually the tech might not exist because we getting better and better to detect smaller amounts of DNA. That
Uh
maybe
huh.
one day there could be a means to
Well, I mean, we're
discover.
trying.
Yeah,
We're trying. Like I really hope that that happens, but I've got to temper that hope with the understanding that like DNA is so fragile and it tends to break down so quickly that you know if the youngest non-bird dinosaurs are 66 million years old, then that's a long time for any tiniest shred of DNA to last. So
but remember
I
that's
don't
not
expect it to happen, but I will be very pleasantly surprised,
that,
overjoyed
and that's nothing like.
if we do get any dinosaur DNA. Yeah.
And actually, like in our field, DNA is extremely stable, is what I was considered, right? Like it's RNA
Huh.
that if you
Uh huh.
look at the wrong way or you breathe on, it's gone.
Yeah. Uh huh.
And so it's like probably RNA was not going to happen, but like DNA could.
But
And so
you can extract DNA from like specimens in a museum collection. We were talking all about museum collections on my stream today. You might have like the pelt of a Tasmanian tiger, a thylacine, and that will have maybe the complete sequence of DNA in it if you extract it carefully enough. And even though
yeah,
that might be like 100 years old or something, yeah.
some of the new species of the week that we discuss on like Science News on Fridays
Hmm.
have been like looking at museum collections and just where the animals look very similar, but when you do the sequencing, it's like, wait a minute, the regions here are so different. These are actually different animals, and then when they do
Right.
closer measurements, it's like, oh look, actually, if you measure like the scale number for this lizard or like these more
Uh huh.
subtle measurements, it's like spine number, like vertebral number of these. It's like there's one extra in this species versus this one that had just
Uh
been
huh.
missed, which is kind of cool to be able to have and go
That is
back to
really cool.
museum sources.
Yeah. Yeah. Wait, so you're saying that new species of living animals, extant animals, have been found in museum collections like that?
Yeah.
Let's hope that they're still alive in the wild. Holy cow!
So that's been in
Yeah.
some of these papers. Like,
Uh huh.
the really sad part is like I forget now what species it was, but a few months ago, the hypothesis was like they might already be gone
Uh huh.
because it
Oh
was like we
boy.
tried to go back to the collection site where these were held, and we
They're
found,
no longer there.
yeah,
There's a Walmart there now. Yeah.
or an invasive species, or like, who knows what
Yeah,
comes
yeah.
in.
Uh-huh.
But so with this gentleman here, he was trying to identify aging and seeing like how aging happens, and like trying to build a clock, like to get to James Karen's question, where I can take a tissue sample from you and predict how old you are based on molecular markers. So like
Right.
we all, age at different rates, but your number age isn't probably representative of how old you actually are on the inside, right? Like if you're
Sure.
keeping good fitness and you're eating in a certain way, your metabolism's a certain way, like there's a lot of factors at play. So as a predictor of like longevity, how might like almost having a clock, and like if I could take a blood sample from you and be like, okay, you actually aren't doing so hot, we need to change around some of your method, like lifestyles, to make sure that, because you have accelerated aging inside. And so what was really, really cool was this gentleman who was doing this research. He's a twin, this Horvath character. And twins.
Wait, that makes me wonder, Balint, how many geneticists are twins? Because I wonder if that might make, not, I'm not saying that like both twins are geneticists, but like how many geneticists do you think there's a disproportionate number of geneticists who are part of a twin pair like that? Because twin studies are a thing, and like, nature versus nurture. I wonder if that would be an incentive for somebody to become a geneticist. Kind of like, have you ever read that there's a disproportionate number of ichthyologists, fish scientists, with the last name Fish?
No, really?
Yeah, it's a thing. Yeah, yeah, and it's like, well, if your last name is Fish, it's like you might be more inclined to like fish, and that might eventually lead you down the path to become an ichthyologist at some point.
I love that. No, I honestly have not heard of a story where it's like these two, like that there is a twin like this is the first time I've heard of it. Obviously doesn't mean it doesn't happen, but it's at least not visible enough. But you're 100% right. Like twin studies for epigenetics is extremely important, because it's that nature over nurture. Like you're genetically identical.
Yeah, but you're essentially like, we can't clone people yet, but like identical twins are natural clones.
Yeah.
And so, yeah.
And so we had a question like, aging is that telomere length. So it turns out, Wombat, telomere length is not indicative of aging. All that is indicative of is cellular senescence, which is when a cell stops dividing. And it turns out that has an extremely weak correlation to aging in humans, and no correlation on other animals.
Wild.
So it's like, it's actually not telomere length. So this guy actually was trying to find something that predicted aging, and he did look at telomere length, and it wasn't that. And then so he got asked by a fellow researcher, like, hey, I'm looking for twins. And the guy wanted to find the genetic basis of homosexuality. And so Horvath's twin brother was homosexual, and he was heterosexual. And so the guy was like, can I sequence you? And so they were like, sure, sequence us. And as you might predict, the guy didn't find anything. Right? There was no genetic cause of that.
No genetic marker, yeah.
Yeah. But Horvath was like, I now have my brother and my's like DNA sequence. I'm just gonna look at this. Let me just look at our sequences. And he was,
while it's here, you might as well page through it.
Yeah, which is, I'm like, all right. I love that story of like, he's just curious. Like, let me see if there's some differences. And he was finding what are called CPG islands. So in the DNA, there is a repeat sequence of cytosine, and then something, and then a guanine. And that something could be any of the nucleotides. So that's why it's CPG. Okay. P is just, you just fill in whatever. And there's an extension of them, so multiples of these. And what happens is they get methylated. So a methyl mark, a CH3, is chemically added onto it, and that closes up the region of DNA.
Okay.
And he was finding, he's like, there's differences between us of this methylation mark between our tissues with my twin. like, why could that be? That's strange. Like, we're genetically identical. Like, there's something weird epigenetically going on here. And so then he downloaded access to like 8,000 samples of like publicly available database of different tissues from individuals, where you had like human samples where it's like, here's the age of the person, here is where you got the sample from, and like just a lot of data. And he found that there was in fact this molecular clock that was at play. And so here is the prediction of, if you have increase of these methylation marks, you're biologically older than if you don't have these marks. And so it's like unmethylated state is this young state, and methylated is old. And he was finding with pretty good reliability, like almost predicting for, you know, faster aging and like mutational states. And which I was like, you know, that is a really, really cool finding, that you're able to find and identify something that clean cut. And, you know, some of the genes that he found that were marked. So he found 363 genes that you can now screen for. So you can take any person, take a sample of their tissue, and check for 363 genes in the genome and see, is there any methylation on there? And that collective number gives you a measurement of biological age. And so some of the ones, the genes that he found that, you know, I think make sense. There's one that had been observed in aging and cancer in the past, like increase in disease state. Another one that was methylated prevents this cellular senescence, so this slowing down of cell growth was affected. There was a member of nuclear transport that was affected. There was T cell function, so immunity was affected. A transporter that's associated with Alzheimer's was affected. So it's like all of a sudden these disease states that you see in older people were affected genetically by this methylation mark. So the methylation.
When you say affected genetically, what do you mean by that? Can you?
So it's when you have these marks on the DNA, it tends to close up that region. So it's almost, it's not exactly, it's not a mutation right in the genome, that would turn off this gene, but instead it's an epigenetic effect where, think of like this red circle on the DNA. You put this mark on there called the methylation mark, and it closes it back up. And so it's almost like you're mutating the gene and turning it off. But instead of like a base pair mutation, you're closing it with this like CH3 mark.
Interesting.
Yeah, wow. So it's mimicking...
And it would be an epigenetic effect, because it's not something that's well, it could still be heritable, I guess, if it's epigenetic, but...
That's where it gets... It's like the complexity is insane, right? Because you can get heritability, like you said, of epigenetics. But here, it's like, they haven't looked at heritability, and because some things get reset upon inheritance and other things don't, and so they're not yet fully convinced by this model, like, or this time to have gone into transgenerational effects. Like, they just have to figure out first, like, in a person here today, how does it work? And so, like, for example, one gene that gets affected is this one called P53, and that's like the master regulator of cell division, where almost every cancer has a P53 mutation. Azure Fire, thank you for the follow. Welcome in. And hi, Alex. It's good to see Alex Vixen. So that gene gets methylated as the person ages biologically, which then means you're more likely to have a disease state of like some kind of tumorigenic something, because you've turned off the master regulator that prevents cells who are sick from dividing.
Right. Okay.
So, Hanny, what decides what gets methylated? That's a great question, Hanny. That level of detail, they don't know. So right now it's more, they were trying to identify what is the connection between aging. So how do you go from this young person to an old person and predicting it? The next step, once they it's variable, Hanny. That's the issue, right? Like, the model's not perfect, but if you can predict very closely on terms of resolution, your next step will be, okay, so what are the factors that contribute to it? You can't test it in a human, though, right? That's the hard part. You can't confirm your theory. Here, all they can confirm is, like, if I take these samples and I run this sequencing analysis on it, if there is this methylation or not, and what's the age of the organism, what's the age of the person. And Danny, where I thought you would get a real kick out of this, is this paper, where he got a grant to do this same experiment, but in 200 different animals.
Very, very cool.
And,
here, and hold up that for, I gotta check on my 3D printer just made a weird noise.
Uh-oh.
I'll be right back. Give me 15 seconds here.
Yes, sir.
Okay. Okay, no, we're good. We're good. Sorry about that.
I tell you, the 3D printers.
Live broadcast.
No, it's. Yeah. I've had prints too where I'm like, I should be checking on this. It's in the garage. I should just run out. I should just have a camera on it. It's probably fine. Yeah. 14 hours later, it failed 9 hours ago.
Yeah. I had that happen yesterday. I lost like a 13-hour print. It failed in like the 12th hour because it ran out of filament. And it didn't. I tried to reload the filament really quickly while I was showing a video to chat. And then like it didn't actually take the filament properly. So it was just going around without extruding any filament. And lost it. So I wasted a bunch of filament. But that's okay. Yeah.
That's it. I think if folks go over to Danny's stream, I think it's wishlist, !wishlist. You've got a list of filaments that people can purchase and help. Like some of the 3D prints y'all you see on Danny's wall. He can use these. Yeah, there you go.
Look at Triceratops skeleton right here.
That's so cool.
This was printed entirely with filament that was provided by members of the community. So yeah,
it's so that it looks real, Danny. like I know it's real, like in a print, but it looks like you actually have a baby Triceratops in the background, like skeleton. It's so cool.
That's the idea. I haven't even painted it yet. Wait till it's painted, Balint. Holy cow!
It looks God. I love when you did the coelacanth painting too. Like it turned out so freaking good for Fishmas.
Thank you. Yeah.
Okay, so Hanny's wondering, is this useful for veterinary medicine? So Hanny, he has done like this absurd number of mammalian animals to be able to do aging studies, and actually the hardest sample for him to get was pangolins, which I thought, Danny, you might find cool because you have a whole like day for pangolin day. Yeah. And before this study, it was not known how old pangolins get. Because in part, like you've talked about and we talked about, they're hunted for their scales because it's like it's considered medicinal in some cultures or like something
traditional Chinese medicine, which is neither traditional nor is it Chinese nor is it medicine.
Yeah, I think was it virility usually, right? It's
who even knows? I don't know.
There's like no evidence to suggest that like what people are using pangolins for even like there's anything there beyond the keratin of their scales, right?
Might as well be ingesting toenails.
Yeah.
It's the same substance.
And so because of the rarity, people had no idea, right, of how old they even get. And so with this technology, they were able to find out biological age, and there's like a conversion of like what chronological could be. And they found one that was 37 years old.
Wow.
And so before
that's really cool because pangolins belong to this group called Pholidota. They're close to carnivorans. It was a mystery for a long time who they're related to on the mammal family tree. But normally with mammals, the way that you can tell how old they are is looking at their teeth. Pangolins don't really have teeth. And so it's like a big mystery, like how old are these critters? The normal method for aging them doesn't work. So that's super, super cool that they were able to do that. I was not aware of this.
Yeah, and it seems to actually work across, like, again, he did all 200 species, and this grant that he got, he was like, it was in an interview, he's like, there's no way I'm going to get this. Because it wasn't from, like, a government grant, it was from a private foundation.
Oh.
And so with that, it's cool because if you get that private foundation money, it's not tied to, like, they can put a clause in that the university can't get it for overhead. It has to be all for research.
Yeah, yeah.
And it
All the
started,
money has to go toward the science.
yeah, not like, I think in Harvard it's like 90% is overhead.
That's nuts. They take 90% of your money to shovel into their. And Harvard has like a $50 billion endowment, or is it $1 trillion? I forget. But they like their endowment is larger than the GDP of like half the countries in the world or something like that.
Yeah,
It's insane.
like, uh-oh.
Yeah.
But so he got the money and he was like, oh, all right, well, let's do it. And then it was working so well that he was calling zoos across the world. He was calling like wildlife sanctuaries for samples. And so I just thought it was like a really cool story about the perseverance of this guy who serendipitously found, like, because of his brother, he was part of a study and he was just like, let me look at the data. And now he's got a model to predict biological and chronological age of mammals. And
So,
imagine,
this should be a movie.
yeah, right?
Like it's a Hollywood movie.
It's really cool. Like, I think he looks at
cool.
10 or 15 different whale species. So like the whole genus of whales, like he can like reliably has a lot of members. So it's like the power and how he's doing it, like, is really remarkable. And actually, it solved the riddle of why naked mole rats, which
live so long.
Yeah,
or why they don't get cancer.
So why they live long? Because like mice, are close relatives of naked mole rats, relatively speaking. Why is a mouse?
They're both rodents, yeah.
Yeah, like 2 years, and why is a naked mole rat 37? And it's because you look at the epigenetic clock, those 314 genes, and their methylation rate is so much lower compared to a mouse, where the mouse at age 2 has all those sites heavily methylated.
Yep.
And it turns out if you artificially change that methylation state in a mouse, you get it to live longer. And it's like, how cool is that? Like that.
That's amazing. Yeah, and I mean, not to be overly like practical applications focused, but like that seems like the sort of thing that people should be interested in for human applications. Like that's a potential like fountain of youth right there, except it's real and based in science, and it seems like the sort of thing that people would get excited about, even outside of the sciences.
I mean, I would hope so, right? And actually, so this was like, here is I think, Danny, I'll put this into the chat. Hold on. Because y'all might, it is open access if anyone's interested in finding it and reading it. But here is like one of the figures, and it's like looking at like the varying clocks and how quickly they age, and like all the species that are looked at, and it's just impressive of how much data is here. And like, California sea lions, Danny, are you interested in how quickly they
Xylophus californianus? That's our state marine mammal here in the beautiful state of California.
Yeah, it was like, maybe are you interested in learning about how quickly they age? It's like, I don't know, maybe. All right, sure, let's give that a try. And so you can, like, the data's free. Anyone can download it and see it. Or like evening bat, spiny mouse, opossum, pale-nosed bat, a pig. There's just such a huge like different things that are looked at. It's like, all right, this data I feel like is pretty good, like in terms of the model.
That's pretty awesome. Yeah. What's this guy's name? I want to look him up.
So I'll put it in the chat too, but the last name is Horvath, and if you Google Horvath clock, he's the everything on the first page, right? Like everything's popping up. There's wikis on him, there's interviews, there's podcasts, and it's really changed the field. And it's, then there's a lot of people, right, who jumped on this research because it's trying to help, like, okay, it is not 100%, right? It was developed on tissues, and there's still variance. Like, you want to get those correlations right as tight as you can. So for example, here y'all can see the dotted lines are not going perfectly at 45 degrees from like the 0 to the corner. Like, a perfect correlation would be a perfect 45 degree line. which means there must be other things that are at play for biological aging. And it's, it's actually pretty good. Like, the Homo sapien one is, the correlation is 95%. Like, it's dang good, but there's still some variance, right? And so the paper that I picked for us, which I promise I'm finally getting to, was this one on immunity. Oh, here we go. The role of immune cells. And so the original Horvath model doesn't take into account the immune system and how that takes, like, how those cells might be influencing it. But there were genes, right, that we talked about. One of them were, like, immune genes were marked differently.
Right.
And so here they're looking at different cell populations. So they were taking blood samples. And they're like, how can we incorporate into the model the idea of immunity? And how is that, like, does it make the model better or does it make it worse? And so what they actually find is it makes the model better. So if you take into account, like, your immune memory cells, if you have more of those, that suggests, right, you've been undergone more immune challenges and, like, threats to your health. That seems to accelerate aging. Which it kind of makes sense. But it's cool to say the molecular reason for it. Like, that this is something that does happen. And Alex linked for us the epigenetic clock for the Wikipedia article. Thank you, Alex Vixen.
Nice.
And so it was really interesting to be like, they wanted to make the process, like, easier to identify. And Space Wizard, thank you for the follow. Welcome. Like, easier to identify and, like, figure out what exactly further accounts for the variability, and then how you said, Danny, in terms of that fountain of youth, right? Because this is taking into account disease state that you might currently have or you may have had in the past. Like, you might be not sickly now, but what if first 30 years of life you're always sick with something? And apparently that does affect your opportunity for a longer lifespan, which is interesting to think about.
Yeah. It does make... If you drink from the wrong grail, it's not gonna end well for you.
If you choose poorly. And it's just cool that there's something, like, it makes sense, but it's cool to see it. And so I started,
that is really, really cool.
Like, mentally rabbit holing on, like, how it hasn't been applied to birds, but I wonder if it can be. And then it's just a stone throw from the dinosaurs. Like, I know you need genetic information, like we talked about, but what if you didn't have to rely on bone to get the age of the animal? Like, what if you could have found out, like, this animal aged more rapidly because of, like, different stresses throughout life, and how that might affect the interpretation of, like, when digging up, like, obviously I'm jumping very far ahead, but you see, like, there can be a link between the two fields here if you can extract the DNA.
I mean, you're talking about stuff that's way up here, and we're still, like, down here, just, like, digging up the bones and maybe cutting them open to figure out how old the animals were by counting the growth rings in the interior of those long bones. But, like, who knows? 100 years in the future, this sort of thing could be huge in the field of vertebrate paleontology.
And Claire Burr's mom, I believe that is, in fact, our Claire Burr's mom. Thank you for the follow. Wow. Welcome on in.
Yeah, holy cow.
And so, like, they did make some interesting points in the paper that they couldn't answer, which I think is interesting. So, like, they looked at accelerated aging in terms of a clinical piece. So there's a disease called Hodgkin's progeria, where you look at a kid, and the 9-year-old kid looks physically like they're 80. And then if you look at their cells, their nuclei... this happens normally in aging. When we're young, we have nice circular nuclei. When we're old, they start blebbing and, like, start to be misshapen because, things are kind of breaking down. A 9-year-old kid had cells that looked like they were 80. And this is something we still can't cure today. And the lifespan of patients are, like, 14 years because they're undergoing rapid aging. It's if you want a good cry, you Google that disease. Golganak, thank you for the gift sub to Claire Burr's mom. Claire Burr's mom. Please enjoy the
Brilliant.
ad-free viewing and the emotes made with love. And there is your daughter, the lovely Claire Burr.
Excellent.
And so, yeah, like, they looked at that. You might predict, and at least I would have predicted, that this biological aging clock maybe can apply to those patients too, as kind of like a slam dunk to show that it works. But it turns out, like, their aging, they don't have those increased epigenetic marks. So that
really,
that's which I thought was
disease. They don't have that.
Yeah, and so, like, I guess
Interesting.
that, like, in this paper they were arguing, like, that suggests that there must be other factors at play, right? Like, we haven't found the only thing that causes aging.
Right.
Or, like, the genes that we're checking maybe aren't inclusive enough yet. Maybe there needs to be something else. Steven the Shark. That's relevant for your stream yesterday, Danny, with the Megalodon. Steven the Shark, welcome the heck in, Raiders. How was your stream? Tell us all the things, Steven the Shark. How was Pal World? That, for those you don't know, is like Pokemon with guns that just came out recently. It's the #1 Steam game.
Oh, no.
Yeah, it is the #1 Steam game on, like, everywhere right now. It is taking over the world.
Is that what it sounds like? I know there was a Pokemon Safari game where you take pictures of them. In this one, do you shoot them? That sounds dreadful.
Pokemon with the Safari game was cool, right? Because you're like an ecologist. This is like, it's a different company entirely, but they're doing it's like Pokemon-like characters, but then you have, like, weapons and you, like, shoot them and you still catch. But it's still cartoon style. Steven the Shark, how was the stream?
Oh boy.
It's like Ark with Pokemon instead of dinosaurs is the other explanation too.
That's not a good way to sell me on that, Nick Saras.
Oh, Alex says you usually don't shoot them. You give them guns.
Oh. Wow. So it's like the opposite of a gun buyback program, but for knockoff Pokemon. That sounds like a bad idea.
I've seen people play it. I got confused when you're this human and you're hitting a rock for 30 minutes building stuff, and I'm like, my attention span is gone. But I hope Steven the Shark, your stream was lovely. I hope Pal World was fun. Welcome the heck in. My name is Balint. I'm 1/3 of SciAnts streams. The other 2/3 are my wife Lita and our daughter baby Alona. And this is Professor Danny Anduza of Paleontologizing. And we are doing our weekly crossover talking genetics, fossil science, and more. Welcome the heck in. And for everyone who's here from the Twitch front page, from the raids, in the channel description today, there is a hot link you can click called Paleontologizing. It's at Paleontologizing. You click his name, and you'll follow the lovely Danny as well, who does dinosaur streams, both from his office and the field, 5 to 7 days a week, depending on the season. Please go follow Danny. And he's also 9 points away from Partner Plus. You know, there's like 7 days left, or 7 days left there.
I think we might get it, Balint. I think we might.
I don't know if my resubs come up this month, but that would be 6. So then, you know, we're close. So please,
not to count any chickens before they've emerged from their eggshells, but it looks like we're gonna get it. Pretty excited about that.
And they
That's
actually,
how I was able to subscribe to you at tier 3, to resubscribe there, trying to spread that love. And are you?
We are not.
Is the Partner Plus goal within sight for you yet, Balint, or still a ways off?
So they actually are. They had an announcement today. They changed it from 350 to 300 starting next month. So it won't affect you like today. It would affect you next month. And they're opening it up to affiliates as well, which is really cool.
Nice.
And there's a second level where if you have 100 sub points, it's a 60-40 split.
Wow.
But
I didn't hear about this.
We're getting closer to that 350. We actually, under the screen, if anyone's on the desktop, you can scroll down and see our progress on how close we are. And Lita and I, we were doing the math today. We're like, this could actually work. Like, if we can get that, so we're like, oh, this could actually work. Like, and that was, we're like, man, if we get that, and if that ambassador application comes through, like, that's it. Like, we can support the family.
You're cooking.
Yeah. So, Thank you all for that support, by the way. All your subs mean for your not just to us, but your favorite streamers. Like, it makes a world of a difference. And soon to be all streamers. That's rolling out at May 1st for affiliates as well. So if you're an affiliate, that's how you can also level up.
Nice.
Lenina, I'm not sure. I know it's underneath the I don't know if it shows on mobile, but on desktop, if you scroll under the video feed, it shows you the that change. No, so they changed it, Alex. If you make 100K from the split, it's still 70-30. They changed that as well.
Really?
Yeah. So if you make, it used to be if you make 100,000 with 70-30, it reverts to 50-50. But at today's announcement, they were like, even if you exceed 100K, it stays 70-30. The only
Let's
thing.
Let's get you there, Balint. Holy cow! Let's get you to 100K.
No, you first. First, Danny, you. The only decrease they had today was from
190 at the top, but yeah.
From Prime subs. Regionally, you might not make 250 from it anymore. You make I think local price like 225, so a little bit less.
Gigantor 56 just subscribed for 4 months.
3 months in advance at tier 2. Thank you, Gigantor. That's a big.
Gigantor, yeah.
That's two.
Awesome.
That's 2 points added. Thank you, Gigantor. Yes, that's how it works out for. And this is not just for us. This is for Danny. Other partnered streamers you want to support. It's 1 point for tier 1, 2 points for tier 2, and 6 points for tier 3. And gift subs and prime subs unfortunately don't count. So it's all like this organic growth meant to be. I think it's meant to be so that someone can't just like you can't just self gift subs, and rig the system, which is
you can't set up a stock account and then give yourself 900 gift subs.
Or your parents can't do it, right? Which would be kind of I mean that would be cool as well, but like can't. And
My parents don't have that kind of money.
I mean. Listen, when we were in graduate school, this is like the life of a graduate student. We told our boss, like, hey, can we graduate in June because that's when our lease ends? And he was like, well, why can't you leave in January? And we're like, because that's 6 months before our lease ends, and we'd have to break the lease, and that's a big chunk of money. He's like, well, just get your parents to pay for it. We're like, what? Like, they can't afford that. Like, my... And he was like, well, that's what my wife's parents did for us. Cool, man.
Just the class obliviousness of some people, especially in academia, is endlessly frustrating. Just, I remember when I was, in undergrad, I'd be talking with, especially like when you go to a conference, and it would be like, the people who stay in the host hotel. Maybe you have dinner with them or something, and be like, oh yeah, back when my grandmother was getting her second PhD, we used to summer in the Alps, and like, what are you talking about? Goodness, I don't know. Like my parents didn't go to college. When your grandmother was getting her second PhD at the Sorbonne, like, must be nice. Must be nice. Holy cow.
And Plockman, thank you for continuing your gift sub from DCing you today. Thank you, Plockman. That's another Partner Plus point. Thank you. First time chatter Norin says the only response was, okay, will your wife's parents pay for us too?
Yeah.
Oh, and Hogan said that too. Yep. You used to be able to do that stuff on a professor salary. So, Reiko, we were told... So, apparently this is for professor positions in California. Some, like, the U.S. SD schools. Oh, and Alex as well. Alex said it too. Nice, Alex. Oh, yeah. Ken, they did that for me, too. Yep. Our PI told us, like, oh, you should go to a California school. And we were like, oh, we don't think we can afford it, like, with the postdoc salary. And he's like, well, when you be a professor there... you can rent a place from the university because your pay is so low you can't actually afford to buy a place, and the rent price are probably so low, so you can rent from the university at a low cost. He's like, you can sign a 99-year lease with them. I'm like, yeah, that's the dream. I want to rent from the university forever. But yeah, like, just the comment of like, yeah, you can have your parents pay for it. Like, that's not how you know, our parents love to help us when they can, but like, you know, my sister's in medical school and my brother's in college, and like, you know, they're getting older. My grandmother's sick and they have to pay for it. Like, my mom's like, we'd love to send you money, but like, you know, we.
Yeah. Shoot, I've had to help my parents out with stuff financially before. It's,
Yeah. Same with like, you know, Lita's mom. Like, Lita's always there and making sure, like, doing stuff for her because like she has Alzheimer's now, and it would be like, you know, it'd be great to afford someone to take care of them, but like that's not something that on our salaries we can do. So it's like you make do with what you can, but it's a weird thing to say, you know, something like that. And Magister, thank you for the 15 biddies. People with Irvine, students, postdocs, basically ran from the university. Yep, Reiko. Yep, that's what was told to us as a great reason to go. And we're like, I'd love to go to California because there's cutting edge research done, but it was just like the way it was pitched, like financially, it's really difficult to be able to do well there. And like, if you're not lucky and that someone has a place to live, or like it's maybe like the best research is being done there, it's super difficult to be able to navigate that.
Yep, it's frustrating. Like, as researchers, we have to, like, we've got to work in the margins, or be like, I can work in this particular place, I can go to this school because I've got a cousin who lives here who can give me a place for free. Or like, it's always got to be something like that, you know, where we can't make it by market rate because we just don't get paid enough, you know. It's always got to be like extenuating circumstances. It's always got to be edge cases like that, and it's so frustrating. Yeah.
Oh yeah, Jim, with tuitions skyrocketing, that's not going to the professors. In fact, Jim, a lot of schools have instituted getting rid of tenure. In fact, so like my dad, for example, he's a medical school professor. His salary is extremely low. In fact, for a med school professor, like we are talking, you would assume a med school professor would make over 100K. He does not, and that's after being in a position since '91. Like with the yearly additions, right? Does not make it, and he's got tenure, and what they're instituting now is they're doing tenure review every 5 years, meaning they can get rid of him before his retirement, which he's getting close to. And they added like, they probably aren't going to get rid of me, but it's a great way, like, as you're aging, you're adding up in prices, you can get rid of someone and get someone new. So yeah, tenure isn't a thing anymore, at least not how it was. And the tuition going up, Jim, is not going to the professors. I don't know where it's going, to be totally honest with you, but it is not going to the professors.
Or one of the papers that we were looking at last week, Balint, I had a colleague who wasn't like an author on one of those, and he was an adjunct professor who had graduate students, and he was getting paid like, I think it was like $12,000 a year to teach multiple classes, and he was working like probably 50 or 60 hours a week, bringing in huge grants and everything, and it's nuts. We're like, I don't know if they'll ever make him tenure track. I hope they do, but like that sort of thing seems to be dying. It's really disconcerting.
I mean, we were talking about Harvard earlier. They have a program where they bring people in, and they give you 6 years, and then you're gone.
Yeah,
like that's it. Like there even if you have like this massive grant and you've done all this work and papers, it doesn't matter. It's like you're gone. Probably because then you have to be paid more.
There was an article that I was reading about adjunct professors at Harvard, many of whom were like living in their cars because they could not afford rent. And this is an organization that has an obscene, disgusting amount of money, and they don't want to pay their professors.
Yeah, I've heard some people say a lot of it goes to administrators. Like almost,
the massive administrative bloat. It's insane.
Yeah. Where it's like the people managing the people who are managing the people who are managing, and versus like...
Yep, and it's just these medieval fiefdoms that develop where it's like these, you know, like, oh, I'm this medieval administrative lord and I have all of these barons under me and I'm so important because my secretary has an undersecretary who has a team of advisors, and it's just, it's maddening.
And that's why the healthcare is also ballooning out of control because it's like, again, the administrator setup, and it's
everybody wants a cut at every level. You can't just have the government negotiate prices for drugs. It's got to go through these private companies and all these executives. They need a fourth vacation home. They need to buy a sixth yacht.
Danny, how else are we going to have that vacation in the Alps, sir?
Exactly, right? Yeah. Oh boy. Anyway. Yeah.
Think of the children volcano. Oh, no, I don't.
Exactly.
We've already started 3 college funds for my daughter. Like 2 family members and us have started a college fund for her on the assumption that it will be a state school, which used to be like the easy, quote unquote, in terms of affordable, right? Like, not that it was cheap, but it was like with the idea within reason for most people to have access to, right? And now that's something where that is gonna be the $60,000 a year.
Yeah, nuts.
It's very frustrating, but
we'll
see if it holds. Anyway, aging.
Yeah. I feel like I'm doing rapidly during this discussion.
I know, yeah. Which is actually, to bring us back to that, they did mention that like stress is something, as Wombat says, that is contributing to. It contributes to a lot of factors, including inflammation, which they've said a lot of inflammatory genes that like reduce inflammation started to be marked with those epigenetic marks, right? Which means that they turn off those things that are suppressing like out of control inflammation. That's increasing, meaning that your age is also increasing.
Right.
So stress, y'all, is another one that also accelerates this aging per this clock. And so the reason it's important for this study talking about immunity is because immune genes do yield inflammation. Like out of control inflammation is one thing that they looked at, which is like an autoimmune disorder. And they found that those people who have autoimmune disorders flare up actually have hallmarks of accelerated aging in their bodies because of the increase in the epigenetic marks. And so it made the model easier, and they were able to take a blood sample versus having to take tissue samples. They did mention in the study that, for personalized medicine or, applying this to other animals too, you still probably need more sample right now than just a simple finger prick. Like, that would be a dream to have just a blood draw, but it seems like it's important to look at a bunch of different tissues right now because there are tissue differences. Like, imagine if you're drinking really heavily and you ruin your liver. That might not correspond to the rest of your body yet, but if you take a liver sample, that will have a lot more hallmarks of aging than maybe your lungs. And so it is going to be dependent on a lot of those different factors, which are important to take a look at. They did give what I liked about this paper, Danny, is that they said they had a limitations paragraph, which I thought was really cool because it's not commonplace. And hi, Dinosaur Dave, welcome in. Do immune cells aid in maintaining youth on a cellular level? So, Hanny, it looks like it's the opposite, where if you have your naive cells that are unimmune challenged, that's a sign of youth. And then as you age, you have more immune memory cells. And those are the idea of like faster aging. So having like a hyperactive or overactive immune response, it seems like is more of a sign of being older versus on that younger side of things. And Dinosaur Dave, Danny sent us some ants from Australia, some preserved ants, like bull ants. Yeah, and apparently they're at customs, so hopefully they'll come through and we'll be able to look at them under the microscope.
Fingers crossed that the customs officers don't eat them all or something.
Well, luckily, legally, we went through it legally, so obviously they're all dead. There's nothing alive, because that's, for invasive species, which we've talked about, is really bad.
Live ant?
No live ants. No. They're actually dead and in sand, so that if they wiggle around, like the sand will keep them
Gotcha.
in place.
Uh-huh.
So we're gonna be looking at them under the microscope once they come through, which will be a lot of fun.
That is super exciting. Some Gondwanan ants from
Yeah.
the southern supercontinent. Very cool. Very
And
cool.
Cobra Cam 15, welcome in. How you doing? So yeah, this is they mentioned, like, they had a whole paragraph on limitations of their study, which I think is super important, especially for something like this, where it's like because if you're just reading this naively or a press report, you could be like, oh man, they discovered how they're going to reverse aging.
Yeah, they discovered the fountain of youth.
Well, but that is the goal, right?
Uh-huh.
Like, I'm totally on board with the analogy, but there might be like this fast jumping, and I like that they're like, here are the other steps we suggest taking. Like, one big thing that they mentioned is, we try to account for 6 epigenetic clock models, and they're trying to improve 6 different ones. The Horvath one being the most common one, but there are other ones too that build on that. They're like, we made 6 of these better, but there are other ones too that we did not test. And so someone should probably look at that. The biggest thing I thought they mentioned, which was really cool, is we did not have enough young people in this study. They were like, ages 5 to 20 was not sufficient, we think, in the study. To really get at this even better, we need more of those patients.
Right.
And so I'm like, that almost seems like a foundational thing that they missed out on. And it could be like, I've had professors were like, well, if we put what might be done better if we put, like, it's almost like a gaping hole in the argument, like, oh no, we're really missing out. But I think it enhances the argument, like, independent of something that you feel like should be done. The data were still good, and it's like, if we could make them even better if we fixed it up, like with this particular, like, addition of samples to really show, like, the hypothesis of unimmune challenged, not so sick kids and young adults, tying that back in.
And how do they word that? Because I can't find this place in the paper. Do they word it like, we would like to do this in the future, or future researchers should explore this?
So the way they say it was, our study included limited subjects in adolescent range. So they accept, like, we're limited on those numbers. Additional cohorts with subjects aged 5 to 20 could enhance the analysis.
Gotcha.
So it's not necessarily that they're going to do it, but it's like they give you 4 reasons as to why this study could be bad. But they provide a counter argument for each one. Like, in order to address this, here's what we would do. Which I feel like is a really neat way of doing it. Like, they're like, we focused on blood, but other places that we compared to focused on tissues. So we should probably do tissue-specific clocks and additional, like, brain and more, to, like, really get at extra answers. And so it's really cool that they have this. Oh, and also they were limited sample size for examining epigenetic clocks in purified immune cells, because of just, like, the public databases that they were taking from too, is, like, not really, when you're getting the immune cells, it's usually a heterogeneous population, so it's like B cells, T cells, like, everything's just kind of together, versus like having a data set where here we took these blood samples and we purified each component, and then we did the sequencing on each component, purified, and put that into a public database.
Right. Okay.
Which, so all of these would make it would much more powerful of data, and it's but it's, like, new enough where it's like, oh, that's really cool that they have that. And so I thought it was a really neat study, and I thought us talking about this clock would be just a cool thing to mention. I thought, especially the Horvath buildup and this big study on all the other animals, I thought that you would enjoy too, because we talk so much about evolution, and like I know it's mammals, but it's fun to think about, like, how this might be applied to birds one day. And then,
absolutely, or it's just cool to see the diversity among mammals like this. This is really, really neat.
And it kind of solves the question of rodents with the outgroup of naked mole rats. Yeah. So is it
very cool stuff? And it's also just interesting for me as a paleontologist, because when we're used to thinking about the ages of animals, not just how long ago they lived, but how old they were when they died, like, my default is always thinking about that in absolute terms, chronological terms. Like, this animal lived this many years and then it died. This idea that that can be accelerated or decelerated, like you have a biological age for it as well, is a totally new way of thinking about things to me. And that's a cool new perspective to have.
And that was my hope.
I'm not used to thinking about it that way. Yeah.
That was my hope that,
yeah.
You know, because I've been kind of picking some of these crossover papers of, like, very naively, right? Like, how can we apply it to both of our fields, even if it's just a thought experiment, right? Like, you said, like, we might not have the tech for 100 years to apply this to fossils, but it's like when you're talking about and looking at this animal that, you know, we've aged via bone, it's a neat thing to think about, like, well, is it really that age in terms of its biology, or has it, like, had something accelerated happen? Because, like, you've shown us, Danny, there have been samples, right, where there's, like, fungal growth, like, evidence, or, like, the animal was sick, right? There has been, like, with the fossil record, and we know what age it was sick at because of the bones, but, like, maybe it was actually a little bit more old in terms of its, like, chronological clock or biological clock.
And we know that there can be situations where certain dinosaurs might look like they're more mature, because maybe, or I don't know, they might look like they're immature. They might be smaller even though they're really mature. They haven't grown to their full adult size because resources were really scanty and these animals didn't get enough food. Or, like, there's another classic thing where a lot of paleontologists used to use this method to determine how old a dinosaur was when it died. They would look at fusion of either the different bones in the vertebrae. So vertebrae, they start off with these zygapophyses on the side, and eventually they fuse onto the vertebra, and that's considered like a sign of maturity. Or the bones in the skull. You know how, like, a baby human chat, they'll have that fontanelle that's open in the back of the skull and then that closes. I'm sure baby Alona has that too.
God, it's the free. It's like, I don't want to touch her. Like, why is it squishing?
Yeah. And so the fusion of those bones is a sign of maturity in mammals, and it is for dinosaurs too, but it turns out that's not a great proxy for the actual skeletal maturity of that animal. Like, even if the bones are fused or if they're unfused, that's not necessarily a silver bullet to determine, you know, like, if the animal is actually skeletally mature. Because we found that in certain dinosaurs, certain parts of the skeleton will fuse up before other parts. Or maybe even one half of the skull is better fused than the other half. And so the more information that we have, the more it seems like this whole thing is a little bit squishy. So usually you've got to cut the bones open and actually look at the growth rings, the lines of arrested growth in the limb bones, to tell how old the animal, how mature the animal was when it died. Skeletal fusion just is not a reliable proxy for maturity in dinosaurs. And, like, I don't know, hearing about this biological age stuff, I'm like, oh no, here's another variable that we have to consider now. Like, oh shoot. It's another complication there.
Yeah, and I guess
which
what
is
makes
cool, but it's also, like, it's a little daunting.
Well, I guess it's like a fun thought exercise, number one, right? And then number two is, we haven't done birds yet, so we should do birds. And then three is, these are all, like, in animals, presumably we don't know what stress state they underwent in life.
Yeah.
So it would be neat to imagine, like you were saying, if the dinosaur underwent stress, right, is that going to be a hallmark of accelerated aging later in terms of biological? Right. And, like, how would that work in a modern day bird? Like, if you can do that kind of test. I don't actually know what level of testing you can do on birds. Like, you know, ants, we could stress them out and, like, no one would care because there's no regulation on it. But, like, you know, within some kind of, like, question of that, and that maybe, like, a question from chat from Sparky is, like, could that have contributed to certain bone fusions and, like, something along those lines? So, you can't test the dino, but you can test on maybe a proxy for it.
A bird or maybe a crocodilian.
Yeah.
An alligator. Alligators are decent laboratory animals.
That's cool. I didn't realize that they did.
Yeah. With among archosaurs, like the group that dinosaurs came from, the most common laboratory animals are alligators, and then chickens after that.
Okay, cool.
And I guess after that, maybe pigeons would be the other bird like model organism.
And I
If
know
anything's approaching the status of model organism, it would be chickens and pigeons and alligators.
and they have finches too. There's a lot of finch labs.
Zebra finches, I think. Yeah.
So I wonder. I think I have a friend who I can ask like what level they'd be able to do on that, because it's interesting, right? Like with this thought experiment. But Alex says
I do wonder if. Oh, sorry. Go ahead.
No, Alex just said dinosaur died when it was 15 years old. You sure? The growth rings say it was sickly animal most of the time. Shut up! Don't complicate things further.
There you go. Yeah. I wonder, Balint, if the genome size would have, if that would throw up some complications for this, like, because birds tend to have very small genomes, and we think that might actually be an adaptation for flight, where like they've got overall smaller cells that are lighter weight because they have smaller nuclei because they have fewer genes. Do you think that might complicate things for this, or is that a non sequitur?
No, I think that's a great and important question, right? I think actually, like, in this data set, it is known there are animals here that have relatively small genomes, and there's ones that have relatively large genomes in here too. So I think they didn't do the analysis in this study to compare that, but actually we'd probably be able to pull that out. Like if we just like Google genome size of each of these animals and just looked and see if there was like a comparison.
Yeah.
I think it.
Do they have lungfish in there? Because I know lungfish have like the biggest genome of any vertebrate.
So unfortunately, only mammals.
Do they have
got
bats
in here, and the aquatic ones I think are just the whale, seals, and I think most of these are terrestrial.
Oh yeah, shoot! These are mammals. Why am I asking if there's lungfish? Sorry.
Well, no, it'd be great if they did. It'd be great if they did.
But yeah, do they have bats in there?
Bats, yep, they do have bats. So
bats have very, very small genomes, and there was a paper that some colleagues of mine at Montana State did, where they were looking at volant animals that can fly, and animals that can fly tend to have small genomes, and we think that might be for lighter weight, like I was talking about with the birds. So I think bats might have the smallest genome of any mammal.
Alex just grabbed it right as we were saying it. Alex is like about 2 gigabase in size. Bat genomes are generally smaller than genomes of other placental mammals, which is about 2.5 to 3.5 gigabases.
There you go. Yeah.
And so I get, and there's actually multiple bat species here that they've tested as well. And it looks like on the molecular clocks, like it looks like it's comparable to, let's see, flying fox, bats, a roe deer, a goat, all have comparable like aging timelines. It looks like.
Interesting.
So naively, this is very off the cuff shooting. Maybe then the small genome is not what's coming at play here, because I would predict then, right, that on these graphs we should see a jump, like in difference compared to neighboring animals, right? So maybe then that's not an issue.
And actually, birds would be really interesting to study, because some birds are very, very short-lived. They only live a couple of years. And some birds can live 80, 90 years. Parrots are like that. Birds within Psittaciformes can be, they have crazy longevity.
Yes, I wonder if they have the methylation marks different. I mean, it presumably would be an easy experiment, right? Like, easy. But those would be good subject animals to test. And
cool
so Sparky was asking, they only did mammals in this study. But it's one of those things too, Sparky, right? Like, if you add too many variables, if it breaks, is it because you added something beyond mammals and like this only works on mammals, or is it because like for some other reason? I think they needed to have a good starting point. Like, this works in mammals, like let's then consider, I think, expanding to birds. They don't mention it in the study, but I feel like that would be a really cool next step to look at. And maybe other organisms as well. And and to make it even wilder, it's like Sparky was asking, well, did they look at the next generation? like from stressed parents versus not. So no across generations yet. So I think Sparky, it's just like, how do we figure out the best data for like within a single generation, a single individual, predicting your biological age, and once we figure that out, maybe that next step would be moving on, like to see other animals, other generations, like what in the model needs to be accounted for and known before you can move on to the next step, right? Because if we move on to the next step and it goes away, or if it's weaker, is that because you're asking the question the wrong way, or is it because it truly is a weaker correlation? Yeah, and let's see, we had another question. So, actual combined weight of the genes themselves might be affecting whether or not birds can fly. Did I interpret that correctly? So I think, Danny, that was for you, for like the nuclei being smaller with like less genetic information.
Yeah, I mean, I don't have the best understanding of this. Not a geneticist. So like, it almost sounds too simple to be true. It sounds like a dumb answer, but I think that it actually is how it works. Like, having smaller genomes means smaller nuclei in each of your cells, which means smaller cells, which means less weight overall. Like, that's my probably oversimplified understanding of it, but I don't think it's incorrect. Yeah.
I mean, it makes, like, I think that the bird genome is generally resilient to what's called transposons or hopping genes. So, like, our genomes are littered with them. They just a genetic element that inserts itself and does nothing. And I think it's like the line gene.
That adds weight. And
exactly, yeah. So I think there's like a pretty high resilience of bird genome to those jumping genes. And that could be because
there might be like, that might be selected against pretty heavily. In that it just makes you, like, you don't need that kind of bloat as a bird. It's really bad for you. As a terrestrial mammal, we can get away with it because, you know, but when you got to become airborne, when you've got to fight gravity like that, like, every last ounce makes a difference.
And I wonder then if flightless birds, if they've lost that selective pressure on them.
That's a fantastic question, because I know the groups of flightless birds that we have today, like ostriches and rheas and cassowaries and emus, they diverged very early. So they've been flightless for like 60 million years or something like that.
That could be a cool thing to look at.
That would be a cool thing to look for, to see if they've had mutations there that have survived, because
or just like you said, the genome size, right? Like, if they're just genome size is bigger, like, that would be really cool if that was
that'd be a really cool paper, actually, to look at that. See,
y'all, this is the beauty of these crossovers. Like, I get so energized for like these. Like, it's not even in my field, but like, let's go.
So this is the thing, is that, like, that could easily be a master's or a doctoral thesis right there. Just that one question. Answering that, you know, could get somebody a doctorate. Yeah, and there's so many things like this in science. I mean, holy cow. There's all these questions that we just think up on a whim, and nobody's looked at them yet, and they're just ripe for the taking.
Yeah. And that's why I thought this was such a cool paper, is because I thought, you know, even if it's a lot just in a thought experiment of how it applies to dinosaurs, we can apply it to evolution pretty easily. And then, like, to birds, and, like, just to back think about what's happening in terms of the dinosaurs and how those animals might have been influenced by this, and how evolution may have, like, framed it. Because epigenetics, like, I mean, I would bet it was around the time of the dinosaurs, too. That seems like a very ancient mechanism. Like, it's a means of genetic regulation is how it is. And so it's, why wouldn't it have been affecting the dinosaurs as well?
Absolutely, yeah.
And so, I thought it was super cool. So that's the paper with the update of immunity, but I know I dragged us through this a lot with the backstory, but I thought it was, again, it was a really fun one to chat about.
And I really like the way that you covered it too, because I remember you picked this paper out for last week and we didn't get to it, and I felt like it was kind of a slog to read through. There was like, and I was looking up videos on YouTube to try and get some background, and a lot of it just still sailed straight over my head. I feel like I have a much better understanding of this, and it feels much more relevant and interesting. So thank you for explaining that really well.
No, thank you. I think the questions too, like, we have from each other, were like, made this like I thought it was cool before, but as we're both like nerding out on it, it makes it all the more exciting of like the future possibilities that could take place, and then how neat it would be like if we just had like Nelf said, like just unlimited money to follow this particular question like even further, and like where it might be with birds. And let's look at that parrot that Alex linked in the chat that's like 80 years old and see like what its methylation state is compared to that bird that, you know, the small one that lives longer. Is it going to be as drastic as the mouse and the naked mole rat? And like, or and you know what, if it totally falls apart and it's a different mechanism, that's also cool.
Yeah, shoot.
So,
compare that to a Galapagos tortoise that might live for 100 years or more, and figure out what's going on there and whether it's something the same or something different. Yeah.
So do you, if you had like the opportunity to get your hands on this kind of data, would you like, and money was not an issue, would you want both to make interpretations about the dinosaurs? Would you want both reptilians and birds at your disposal? And if so, like, are there particular animals that you would be high on your list for us to interpret back to dinosaurs? Like, what you feel like is the closest appropriate representation of a dinosaur in modern times, like beyond just like any old bird or any old reptilian. Like, what would be the prime time organism for Professor Anduza to get that interpretation?
That's an excellent question, Balint. What you're talking about is this like theoretical framework that we have in dinosaur paleontology. We call it the EPB, the extant phylogenetic bracket. And my old crew chief, Denver Fowler, used to rant about this sometimes. He'd be like, "Oh, the EPB, you know, it's just crocs and emus." That's basically what it is. Where it's like, if there's something that there's some information we don't have about dinosaurs because it doesn't fossilize. Like, what shape were their eyes, or like, you know, what noises did they make, or something like that. The way to kind of organize our thoughts about this, and the way to like make educated guesses that are as close to the truth as possible, we think, is by looking at their closest living relatives. So you look at a phylogeny, like an evolutionary family tree, and you look at the groups that bracket dinosaurs. So, Balint, if you were to do an image search for like dinosaurs extant phylogenetic bracket, you might find one of the same images that I usually use for this. Yeah, basically crocodiles are kind of like cousins to the dinosaurs. And there should be one there that's super, super simple. But like, I don't know, you might not be able to find anything actually. I don't mean to send you on a wild goose chase here.
Well,
actually, that one there that's really big from ResearchGate, that might be cool to open up.
Yeah, let's look at this one. That one's a pretty picture of a dinosaur.
And big in that one.
Let's see, where are the figures though?
Maybe you just go back and then do open image in new tab or something. That might do it.
We got the paper. Is it gonna give me the paper? Come on now. Apologies. This is the beauty of a live broadcast, chat.
I know, right?
Here we go.
There we go. Yeah. So there we've got a bird. I can't read that, but is that bufo, an owl?
B-U-B-O?
Oh, bubo. Yeah, that's some sort of owl, I think. Unless it's an eagle. Could be an eagle. And then there's some sort of crocodilian there. That's probably
crocodile.
Yeah. So crocodile, and then Camarasaurus in the middle. I recognize that dinosaur.
Do you recognize
it from the skull? Skull in my office.
So, that's so cool.
Yeah.
So
here, let me go get that. It's right over here. Yeah, I brought this to the classroom on Saturday. I started teaching again in person on the weekends, and I brought this, and the kids loved it. But that's Camarasaurus, right? In fact, this is the same exact specimen, I think.
Wow! It totally
famous,
is.
Juvenile Camarasaurus skull. Yeah.
That is so. That is so cool, Danny. That is so
That's a perfect
cool.
match. Yeah. Anyway, when we're thinking about dinosaurs, we use what we call the EPB, the extant phylogenetic bracket. So dinosaurs, the non-bird ones, are extinct. So we can't examine their squishy eyes or hear them make noises and stuff. but we can look at their modern relatives. And the creatures that are closest are crocodilians, crocodiles, alligators, gharials, etc. They're like cousins to the dinosaurs. And then you've got birds, who literally are dinosaurs. They evolved from small, two-legged, feathered, meat-eating dinosaurs. And so, yeah, if I were to try and think about, like, if we were to try to determine, like, the lifespans of dinosaurs, or do, like, this kind of, like, biological age stuff for dinosaurs, you would look at crocodilians, and you would look at birds. And the birds in particular that I would look at, even though all birds are equally closely related to dinosaurs, because they are dinosaurs, the ones that I would look at would be birds that don't fly, like you were talking about earlier. Flightless birds like ostriches, emus, cassowaries, rheas, maybe tinamous. A group of birds that we call the paleonaths. So this is a very early diverging, very, like, to use an old-fashioned word, a very primitive group of birds that's still around today. We think that they are a really, really good analog for non-bird dinosaurs in a lot of ways, because they don't fly, they stay on the ground. They've got, like, interesting reproductive behavior where, like, the male is the one who sits on the eggs and raises the young and everything. We've got good reason to think that's the same for non-bird dinosaurs too. So yeah, those are the two groups that I would look at: crocodilians and the paleonath birds.
And if money was not an option, or not an issue, how many species? Like,
it's often not an option right now.
It's definitely, yeah. Oh, that hits hard, right?
Yeah, Freudian slip. Yeah.
If it was not an object, you could have unlimited funding.
Yeah.
How many species? And this is, I guess, isn't just for this aging question that we're chatting about, but if you had access to, like, bone morphology of, like, all these animals, like, what is your ideal number? Is it, presumably it's more is better, but, like, is there a threshold at which you'd be like, limited returns?
Yeah. That's a good question. When you're looking at volant birds that can fly, flying birds are weird, man. They're like, they've got this really weird suite of adaptations. Like, flying is such a bizarre activity that, like, when you're a bird and you fly, it affects every aspect of your body. Like, not only do you have hollow bones and everything, like all birds have, or most birds have, but also, like, you only have one oviduct, where birds started off with 2 oviducts, where they'd lay, like, 2 eggs at a time. And now birds only have 1, because there's this, in order to fly, you got to reduce weight. And so that's just, like, one of the sacrifices that they made. That's why birds only lay 1 egg at a time instead of 2. Stuff like that. Yeah. So I guess even with unlimited funds, what I would do is I'd look at all of the modern crocodilians, all 23 species or whatever of crocodiles and their relatives. And then I would look at all of the modern flightless birds, the paleonaths, and let's throw penguins in there too, even though they're neonaths, but they don't fly. It could be interesting. And then look at a few outgroups among the volant birds that fly. Yeah, that's what I would do.
Nice. And then for the crocodilians, we're much more limited, right, on, like, the total number of specimens that are species there are, or is that a naive thought?
Yeah,
like, relative
I think
to the
there's
bird.
like, somebody can look it up. There's like 20 species of crocodilians that are around in the world today. Used to be so much more.
Yeah.
Crocodilians used to be on all 7 continents. Yeah, no longer. But yeah. Yeah.
Cool. That's fun. I think this is a fun little rabbit hole that we went down.
Fun, yeah.
Danny, how long do we have you? I know that Ios and Lordy are out of town, but that doesn't mean that I want to keep you until, like, as late as I stay up.
Give me another hour.
Okay.
How's that sound?
Since we awesome, thank you so much. I know I geek out, and I'm just so grateful to have you on and us chatting, and it's like talking to your SciComm hero and your your SciComm hero and having a good time. It's like, no, I'm so excited. And Alex told us it's 9 genera and 28 species of crocodilia are split into 3 subfamilies: alligators and caimans, true crocodiles, and the gharial and the false gharial.
I didn't know that false gharials were allied with true gharials. I thought they were crocodilids. Interesting. Huh. That's
Nice.
cool.
Thank you, Alex. So since we were talking about vision, should we go to the vision paper?
The one about dinosaurs or
Yeah.
about jumping spiders?
Dinosaurs.
Let's do it.
All right.
Yeah, sounds good. It's a nice segue there.
Here we go. Orbit size and estimated eye size in dinosaurs and other archosaurs and their implications for the evolution of visual capabilities.
Yeah.
I read this title, and I'm not gonna lie to you. I was like, are they gonna be able to convince me?
I was kind of the opposite. I'm like, what in the world are they trying to with eye socket size? Like, what conclusions can they possibly it doesn't seem like a super interesting kind of paper. It's like so what kind of a thing, you know? And it's kind of how the paper reads too. I'm not gonna lie, it's not the most exciting paper, and none of their findings were surprising in my opinion. But it's really cool, comprehensive work where they looked at so many different genera, not just of dinosaurs, but also of other archosauromorphs. So, like we were talking about, the relatives of dinosaurs as well. They looked at crocodilians and a bunch of extinct archosaur groups, and they looked at dinosaurs too, and some very bird-like dinosaurs. I don't think they looked at flying birds, because like I was saying a minute ago, when you're a flying bird, like, you gotta be a weirdo, because only weirdos have the ability to fly. You gotta be like super committed to that. But yeah.
So, KK said that we should have a sub goal that we can have a sleepover and late night stream one night.
I like that.
See, I view that.
And holy cow, Rhacodactylus. Gharials are my favorite crocodilian too, and I'm actually working on gharials a little bit for an upcoming paper. They are by far my favorite extant crocodilian. Gavialis gangeticus, the Indian gharial. Oh man, I love them. Yeah.
It is.
Anyway,
you don't have to answer, of course, because they aren't by chance somewhat proxies for Spinosaurids, are they?
They are indeed, Balint. Yeah.
Oh, I'm so excited
really
for the
hoping
Spinosaurid paper.
I'm hoping I can draw some additional attention to the plight of the gharial through this paper, because everybody loves Spinosaurids, everybody loves dinosaurs, and gharials really need more attention because they are critically endangered, and they need all the help that they can get right now. So I'm hoping to highlight gharial conservation in the paper and all the press that I do for it afterward.
Yeah, they're beautiful animals too. Like, some
they really
of
are.
The pictures
Yeah.
here, like I think they look super cute too.
These are not crocodilian species that attack humans. They've got these long, spindly, delicate jaws, and they only eat fish.
Are they hunted to? I don't know about like why they're so critically endangered. Is it like a fear of human attack, or is it?
It's a whole combination of a whole constellation of different threats. So for one thing, they're susceptible to pollution in rivers along the Indian subcontinent, Pakistan, and Nepal. If you overfish the rivers and they don't have any food, if you set out like nets in the rivers, they can get caught in those and they can drown. Sometimes fishermen will just murder them because they're like, oh, those are eating my fish. And also habitat destruction, in the sense that gharials, they're the most aquatic of all the crocodilian species, and so they're not very mobile on land. They spend almost all of their time in the water, and they don't come up on land very far to lay their eggs, so they need these sandy riverbanks that are right close to the water in order to lay their egg. And they're very, very picky about that kind of habitat. They need like a particular consistency of sand, and sometimes that sand gets dredged up or used for commercial purposes or whatever, and like they just don't have areas to nest anymore. So there's a whole bunch of things that are going wrong for the gharial right now, and they really need our.
That is. Yeah. Wow. So like everything's going against them. In part, it almost sounds like with like wolves, right? In a way. Of like the American wolf, of like, the habitat destruction, the farmers taking them out, like there's just like everything is kind of going against them.
I mean, at least with wolves, like you can kind of leave them alone and they They do their thing. Like, wolves will thrive in our absence. Gharials, it's like we've messed things up so badly for them that, like, they need captive breeding programs just to maintain their current numbers. And when there have been gharials that have been bred in captivity and then released into the wild, sometimes the monsoon in India will just carry them hundreds of miles downriver, and you'll never see them again.
Oh wow.
And so that's like another challenge as well. So yeah.
And I see there's like, one of the first hits is this alligator farm zoo to breed the endangered animal. It's so adorable looking too. Like, it's so charismatic. You'd think it'd be easier to.
Yeah, and they're so unique. Also, like, they're the only crocodilian that's got these super long, thin jaws. There's a group that's trying to, like, educate local people and get them excited and proud about gharials, and they're doing really, really excellent work along the Indian subcontinent, and I wish them the best of luck with that, because this is such a special creature, and they go back to the time of the dinosaurs. Like, this particular family is very, very old, and now there's only one or maybe two species left in the world, and they harken back to another time.
And so
they're such cool critters.
It's interesting how you said that these can be then used as a potential proxy for Spinosaurids. It's almost like going back to this figure that we looked at here, and how you were talking about, like, the different birds and the different crocodilians and whatnot that, like, apply. Like, you can take in and learn about them and use them as that proxy. So does that...
That's a huge part of dinosaur paleontology, is just looking at modern creatures that might have similar morphology, similar anatomical characteristics. If we find some weird thing in a dinosaur, we could just kind of scratch our heads and go like, I don't know what that's for. But if you look for similar anatomical traits in modern animals, that can give you a clue as to why that thing evolved, what that thing is for. And that's what gharials are helping me do with Spinosaurids, with their long, thin jaws and other stuff.
I'm so excited for that paper, Danny. That's like, every time I hear like little tidbits about, like, oh, that's gonna be so cool.
It's a super cool project. Yeah.
Nice. Reiko says it's so cool, I'm gonna geek out when you publish it. Oh yeah, I think for our crossover that week, we're just gonna be talking about that one paper. Like,
it might be several weeks. I don't know. We'll see.
Oh, it's even better. It's like, let's figure by figure how this.
No, it'll be cool to talk about too, like how we do the press for it, and like how it's received, and like, I don't know. I think I'll have a lot to talk to you about Balint, with just like getting a paper published and then seeing what results from that afterward. I've not really done a lot of that. I've not gone big with the press on any of the papers that I've been involved with, and I want to go really big with the press on this one. And so I think that'll be cool to discuss.
I have some connections that we can pull on to make something happen there. So we'll chat about that. I have some contacts that maybe we can pull some people in there. Yeah, because
nice.
It's important. There's like I'll tell you, I'll like hook you up with the person, but there's like this one guy who insists that every paper that he publishes out of his lab, he like does press releases for, and just like, he's like, it might be a little thing, but it's important to get that visibility out on any paper.
Yeah. That's one thing I'm kind of surprised by, is like, as scientists, we pour our hearts and souls into these publications, and then they're just gone. Like, they're not gone, they're in the literature and everything, but like, I feel like you should be having a party and like making a big deal about it, and doing some press stuff about it. And so many of these, I don't know, so much of what I do on stream is like looking at press articles and looking at videos that people have produced about their research. And like, I've got this internal Rolodex up here with like, if we're talking about a particular subject, oh, I know we talked about that in a video here, or there's a video press release there. That sort of thing has an outsized impact, and I think it's about time that paleontologists realize that and start focusing more on stuff like video, or at least press articles.
Well, I mean, I think you have the same issue as we do as well, where there's not press releases and videos. And so I know your Rolodex is similar to mine when someone asks a question about a topic. And it's like, well, I know that there is this totally unrelated video that we can like pull in a segment from, Or same with like our science news. Like there's no actual video on what this paper is.
Yeah.
So we have to pull together 6 different videos that you pre-screen, and like only half of them can you use because it's like, you know, half of it is like not exactly accurate, and so it's like, it's a good way to do a press release to communicate the science and do science communication, like bring it to the public, and I think that should be encouraged if not celebrated.
Yeah, I agree. I'm going to be making a video, or I might do like 3 different videos at 3 different lengths for the Spinosaur paper, but I got to talk to my co-author about that and see if I can get him roped into it as well. And yeah, but it's going to be good. I want to go big with the press for it.
Yeah. KK, can we get a link to Danny's socials? KK, I can do you one better. The cooldown's over, so we can do a fancy shout-out for Danny. You can go follow him, and then all the links are there on his main page. We don't have the paper yet or the press release. KK, that is going to be downstream, but KK, you bet your butt when that happens, we're going to be celebrating that here on SciAnts, okay? Even if Danny's not on, we're going to be celebrating that paper. It's like our game dev friends, like when they publish their game, we're going to be celebrating. It's a huge thing to do, and that's like celebrating our community. So it's, yeah, absolutely, KK. We'll be linking it. But guys, seriously, anyone coming through, front page or not, please hit that follow button at the top of the chat right now to follow Professor Danny Anduza. Yeah, Danny, tell us about this paper.
Yeah, so this is a really, really cool paper. The results aren't necessarily surprising or groundbreaking, but the thoroughness in this paper is something that I really admire. So some of you in the chat might be looking at the title and going, orbit size, like what's this? It's like astronomy, orbits. No, orbit is your eye socket. Your bony eye socket right here is the orbit. And so what they were doing is they were looking at the size of the orbit, the diameter from front to back, like that, and they're seeing how well that matches up with the overall dimensions of the skull. So, excuse me, there's a figure in here where they've got a Plateosaurus skull, and then they show the orbit and then the length of the skull right there, and they compare the two. That's the one. Yeah. And so this is like really, really basic stuff. Like these are kind of low-hanging research fruit. And in this particular paper, Balint, did you catch the part about the students where there were undergraduate students who were actually taking these measurements? I think they were in like a Dinosaurs 101 class or something.
I missed that detail. No, that's really cool.
But yeah. So they were the ones who were actually taking some of these measurements. And then they put that all into a database, and they just plotted it out in a bunch of graphs. How big is the eye socket, the orbit, in relation to the size of the skull? And does this change in different dinosaur groups? Does this change over time throughout the age of the dinosaurs? Does it change through, dinosaurs and their archosaur relatives? And the interesting thing was, it didn't change that much. It's pretty consistent over time, which made a lot of sense to me. Because dinosaurs and other archosaurs, crocodilians and birds and stuff, we think they're pretty visual animals. And so you wouldn't have the same kind of crazy differences, like proportionally between the size of the eye and the size of the head, like you do in mammals. Like where certain mammals will be absolutely enormous, and yet they've got pretty small eyes relative to their body size. Whales are a good example. And then you've got small mammals that tend to have pretty big eyes. Think about like little primate-y things, like an eye would probably be a good example.
Which is a very aptly named animal, right? The eye.
Exactly, yeah. With dinosaurs, we don't really see those extremes in proportions like that. It's like they all have decent-sized eyes, Yeah, so maybe this would have been a paper in a bigger journal if they'd found some sort of crazy result here. But, like, it kind of comports with what you would expect, It's kind of a no-duh paper.
So I had some naive questions then. So, kind of, like, linked how
I'm sure they're not naive, by the way. You just want to, like, denigrate yourself like this. I'm sure they're great questions.
So,
if you're wondering about it, Balint, there's going to be... 100 people in the chat who are wondering about it.
Possibly, hopefully, potentially.
Yeah.
I like the first question stems from what you actually just said about what we know about mammals, right? Like with some of our nocturnal mammals, there is a larger eye in relation to the rest of the body. So sometimes, right? It's like they're like with some bat species, for example, right?
And some bats have almost non-existent eyes.
Right.
Another thing is that
with the
mammals went through this, like during the age of dinosaurs. Mammals were super small. The very most gargantuan mammal during the age of dinosaurs is like the size of a loaf of bread. Like they never got very big. Most of them are like they're barely bigger than bugs.
The way you said
like our ancestors are just they were snivelly little whiskery balls of fluff just trying to survive in a world ruled by these gargantuan dinosaurs. And so as a result of that, their eyesight isn't very good. They became like mostly non-visual animals. So most mammals today do not have very good eyesight. Most mammals today are colorblind. They mostly rely on smell and hearing to get around and to interpret their world. Sometimes also touch. That's why a lot of mammals have whiskers. Because we think they evolved like during the age of dinosaurs for that 160 million years before the asteroid hit. Mammals lived in the shadow of the dinosaurs. They lived in burrows. Many of them only came out at night. And comparatively, after the asteroid, we only have 66 million years. So there's not a lot of time to catch up and become more visual after that. Like, we're an exception as primates. We can see in color vision. But yeah, most mammals are pretty olfactory, like nose-based, and auditory, hearing, too. And so, like, bats are a good example of that, where, like, I don't think any bats have particularly good eyesight. But yeah.
Is it the flying foxes, right? I think the flying foxes.
Yeah, they live during the day. They come out. They live during the day. They live at night too. They come out during the day. They're active. They're diurnal, in the daytime. And I don't know if bats have color vision. Do flying foxes have color vision? Somebody in chat look that up. I bet you they would, because they eat fruit, and that's one of the ideas for why we primates re-evolved color vision, because our ancestors didn't have it. Was to be able to identify ripe fruit. Being able to see color would be important for that.
Yeah, and then it's not just depending on taste when something's gone bad or smell, but having like an additional sense for that.
Exactly. Yeah.
So I guess my question was stemming, and I guess we've kind of answered. Oh, let's see. Flying foxes have eyes with cones, which allow for color vision in addition to rods. Allow for shape and pattern recognition to assist in low light conditions. Thank you, Alex.
Nice. So a lot of mammals almost only have rods. Cones are for color perception, like Alex Fixon was saying. Yeah, and even the mammals that do have cones still don't have color vision that's as good as other animals. So like birds and their dinosaur ancestors would have tetrachromatic vision. So they can actually see more colors than we can. Like they can see partway into the ultraviolet spectrum, which is something that we struggle to even imagine. It's like trying to imagine a color that you can't see is like it's like one of those college dorm room discussions.
And that's insects too. Like insects also see on that level. Raiders, welcome the heck in. Ninja Gloppy and Raiders, how was your stream? Welcome the heck in. Guys, if you don't know Ninja Gloppy, photographer of does astrophotography, does the video game Rocket League, does photography of animals, just came back from South Africa and shared with us a bunch of really beautiful images of the wildlife, and was doing art today. Ninja, how was your stream? Tell us all the things. Raiders, welcome in. My name is Balint. I'm 1/3 of SciAnts streams. The other 2/3 are my wife Lita and our daughter baby Alona. And today is Wednesday, which means Professor Danny Anduza of Paleontologizing is here, and we're discussing fossil science. And we were doing earlier the genetics of aging and hallmarks of biological aging. And so y'all welcome the heck in. Ninja says doing second half foot. Oh, there we go.
Didn't mean for you to pause, but I've got Plateosaurus that's there in the illustration, that might actually be reconstructed from this particular specimen. It's not. I'm not done painting this yet, but this is my 3D print
Oh
of that
wow.
of Plateosaurus.
Oh, that's
Yeah.
really cool. And it's mounted in like what looks like the stone, right?
Yeah. So the original is still in situ at a museum in Germany, I think. And this is a scan of it that I 3D printed, and it's not done being painted, but yeah.
That is so beautiful. It's so cool.
It's the same animal right there. Yeah.
Yeah. Ninja said doing second half of photo editing from the trip, got all finished up, and Zintao's hello. It was a photographic marvel. Nice, Ninja. There's any photos you want to share, you know the drill, drop it in the chat or the Discord. We'd love to show it off. We're just chatting with Danny about this paper about orbital size, so like size like in the bone of where the eyes go and how it relates to potential vision. And I'm asking allegedly naive questions. And Danny's telling me, no, it's
not naive. These are excellent questions. Yeah. Yeah.
And so yeah, feel free y'all to ask questions. We're doing it's our weekly crossover, and we're having a great time. We're doing biological and epigenetic aging earlier tonight, and kind of having dream discussions on what that might look like if we were looking at it in dinosaurs, which we can't because we're limited in terms of the DNA collection. But and speaking of orbitals, this is a photo Ninja Gloppy was editing tonight.
Oh, beautiful! Is that a Cape vulture? Who is this?
Ninja. Yeah. What kind of animal?
Some kind of vulture. Looks like. Beautiful. Look at those blue eyes.
Yeah. And so Ninja was sharing with us last week too some of the photos that he was taking, and like lion and elephant and rhino and hippopotamus, like really, really beautiful, cool trip. And big game, cool. Is that a dinosaur? It might be. Let's see.
I mean, it's a bird, so it literally is a dinosaur. Yeah. No joke.
It was. I said I was at a rehabilitation center with tons of vultures, so not sure about the species. Too many to remember all the names.
Very cool.
Nice. And then there's also a jaguar too.
Ooh, a melanistic jaguar. Super. No, not a jaguar. That would be a leopard if it's in South Africa.
Yeah.
Yeah.
Black leopard.
We had jaguars here in California until very recently, Balint.
Really?
Yeah.
I always thought it was Africa.
No, jaguars live in South America, Central America, and the southern part of North America. There's jaguars that they've moved up across the Mexican border into New Mexico and Arizona, I think. Like, wildlife biologists have been tracking them. Like, there's camera traps that show that, like, yeah, they moved into the U.S. now, which is super exciting, because they used to be all over the place here.
Casey Snowart says there's one spotted in Texas not so long ago.
Yeah, very, very cool. Yeah.
Ninja, awesome. Thank you so much for the raid and for sharing these pictures, especially of your audience. You shared the dinosaur photo, so appreciate you on that, Ninja. Alex Vixen says...
I might have my own Black Panther over here. Hang on. You continue, Balint. Let me see if I can coax her over.
Ninja's like, I did know the audience. Thank you, my friend. We were just talking about bat vision as well, and how it might correspond. And we rabbit holed Ninja into the flying fox, and we mentioned, there's the Black Panther.
Hey, Mini Pie, how you doing? This is one of my feline overlords here.
I like Jaded Fairy goes the landlord visit.
Yeah, girl, Mini.
I have one here next to me too, but she's curled up in a ball in the chair next to me.
Oh, and I've got another one walking around, just like a shark, just patrolling along the floor. Sweetie Pie has also come over. Yeah.
Her eyes are beautiful.
Yeah. Oh, she says thank you.
Oh, and Hanny says Wakanda forever. Well said, Hanny. Well said. Oh, and then speaking of dinosaurs, so this is another image from Ninja on his trip, and Chad, we were talking about flightless birds and how the not so classic term, right, of potentially primitive in terms of relation to the dinosaurs, and we actually talk about genome size and how that might have influenced the flight ability too, and like looking at those connections, which is a lot of fun.
Yep.
These are really pretty too. Thank you, Ninja. I love the camera you're using, by the way. The details are remarkable.
Really nice. Those look like maybe female ostriches there. Either that or immature, but they're gorgeous.
Yeah. And Alex Vixen was telling us, Danny, that with respect to the flying foxes, not only can they see color, but there is evidence from that they were also had the ability to see some in ultraviolet as well.
Oh, interesting. Really, for flying fox? That's interesting.
Or maybe Alex, I'm not sure. Is that for general bat vision, or that was for just the flying foxes? Let us know, Alex. Yeah, and insects can see in UV light as well, so that's like another extra like region of the spectrum that we can't see, but they can. So I guess.
Although that's weird, because like bees, I think can't see the color red, which is why most hummingbird feeders are red. Am I right about that?
So most insects can't see red.
Interesting.
So if you wanna, like, we wanted to simulate a nest for them. And so what you can do is we would pour plaster and then put a yoga mat in there to make like a little indent, let the plaster solidify, take out the yoga mat, and then put a sheet of red film on top.
Yeah.
And the ants moved in underneath, and they thought it was dark underneath. But then you can still see what the colony's doing.
That's super cool.
Yeah, so like infrared is like where they don't have that vision. But then, like, further on, and actually, like, with bees, have you seen, Danny, the images of what bees actually see?
I have not, no. That sounds cool.
So let's see here. This is, like, the really, famous examples of what bees end up seeing. Come on, why is that image so small? I need a better image.
It's like an airport where it just says, land here.
Codex, thank you for the 100 biddies. Codex, I appreciate you. Let me find the images. Yeah, I mean, this is like the classic. Let's do open image. Here we go. So on the left-hand side, closer to me, is what the real flower looks like. And then how the bee actually sees it is on the right-hand side next to Danny. So it's a very different color. And so it's almost like the flowers are, like creating almost a landing strip to guide the insects to be pollinated into a particular site. And it looks so different compared to them. And there's limits in what colors that we see too. And there's, different pollinators that will have different attractiveness. There's odorants too, Hanny, that can act like there's some flowers that mimic the odorants of the mating pheromone of insects to like get them into mate, but then also there's these unique color patterns to see. And even insects can see different UV patterns based on like where they are in the phylogenetic tree. So like fruit flies gain information beyond the UV light reflecting off their wings to one another that you and I can't see under regular light, but they can, and that gives them, there's like mating preference of that, which is really cool.
Very cool.
But so like on my dino question, in this study, because of what they found, are we unable to get information about whether or not these animals were nocturnal or diurnal?
Yeah, they basically say this at the end of the paper, that like if you want to make behavioral inferences about dinosaurs based on their orbit morphology, what you really need are the sclerotic rings. So most animals, except for mammals, have got this like ring of bones in the eyeball.
Okay.
And that will actually tell you exactly how big the eye was, or at least that's a really, really excellent proxy for how big the squishy part of the eye is.
So this doesn't tell us.
It's not as good a proxy.
Okay.
Yeah. But that's the thing, is that we kind of have to. They had to use this for this paper, the size of the orbit, because the sclerotic ossicles, it's only very, very rarely that those are preserved. It's
is it
basically
because of their...
only in like exceptional circumstances that you get this really delicate ring of bones in the eye. You can look up sclerotic ring on Google Images, and you'll find a cool picture, I think, from Wikipedia about this, with a bunch of different modern critters that still have this. There it is. It's the
Together we can rule the galaxy.
Oh, Charlie's Dragon, thank you for the resub. Welcome the heck in with the Danny salute
Charlie's
emotes.
Dragon just subscribed for 3 months.
Beautiful.
Welcome the heck in, Charlie's Dragon. Thank you for that resub. Danny, this image?
So top row, the fourth one to the left. Yeah,
Gotcha.
that one. Yeah.
Okay, so
Yeah,
like
so-
the actual circle here. There's
There's a circle of bone that's inside of the eyeball. And that might be weird to us as mammals because we don't have that, but
Mhm.
like all vertebrate animals except for mammals and for whatever weird reason except for crocodilians too.
huh.
Everybody else has this.
So okay, again, another naive question, because crocodilians don't, and they're flanked on the phylogeny with what you interpret of what dinosaurs are.
Yeah.
What is the assumption that dinosaurs have, and why is it?
So we don't have to assume in this case because we found sclerotic rings in I think almost every group of dinosaurs.
Okay.
I don't know if we have it for Thyreophorans yet, actually, for the armored dinosaurs, but we have it in. I think we have it in sauropods. We definitely have it in theropods. We have it in ornithopods. I think we have it in marginocephalians as well. So we think most, if not all, dinosaurs would have had this too. Yeah.
So, and then presumably with the armored, the likelihood that they would have lost this is pretty low, right?
Yeah. That's because the eyeballs are usually the first part of the animal to get eaten when it dies. And so the sclerotic ring would be one of the first things to get destroyed.
So is
after an animal
that
kills
why it doesn't fossilize? Is that it's not? Is it?
Yeah.
It's not because of the chemical composition, but rather the...
It's actual bone in there, so like that's actual bone that like should fossilize like the rest of the bone, but it's just a very delicate part that's probably also very tasty to scavengers or predators.
So when it does fossilize, is that something where maybe like a bog that the animal falls in, right, or something where you're not
accessed? It doesn't have to be that. It could be like a sandbar in a river or whatever. But it just has to be like the animal gets buried really quickly before that part can get eaten.
Gotcha.
Yeah.
That it.
Yeah.
What is its function? Is it just to move the eye around?
It's to like give structure to the eye, and I think it kind of depends on what the animal is using the eye for. Like different kinds of critters will have different shapes to their sclerotic ossicles and different sizes and different robusticities to them. So like here you've got a bunch of different critters with different lifestyles, and you've got different shapes for those. So if you look at like the parrot or I think there's a Philippine eagle right there, and they've got like really, I think letter I right there is the Philippine eagle. Yeah, and the eagles have crazy excellent eyesight, and that sclerotic ring right there maybe is an indicator that the animal has excellent eyesight. I don't know. Yeah. And
so if like you said, it's hard to get the preserved specimen, but if you got these from the, like you're saying in this particular paper, we don't have those, but let's say you did.
Yeah.
You might be able to infer what the eyes did based on modern comparisons, right? And
you'd have more information than just having the eye socket like we have in this paper.
When you have found them, like you were saying there was some fossilized, are there modern day similar comparisons that you can like look at, or is it...
I don't know if anybody's actually studied that in depth. That might be one of those things that could be a PhD thesis, you know? Yeah.
Cool.
Yeah.
Okay, nice. Again, sorry, naive questions here. But this is that's really cool stuff. Do we know why mammals don't have this, or
it might be part of them not really using their eyes that much for 160 million years? Like, it might be for the same reason that most mammals are colorblind, where like it just became less important to develop your eyes, and like like you were talking about last week, Balint, like when you're developing from an embryo, if you could just kind of like take a shortcut here and there, and grow up faster, you're more likely to survive. And maybe that's one of those things. They just like they didn't focus on developing their eyes, and that was an advantage for them at the time.
That makes sense.
Yeah.
It's interesting that we regained like color vision, or presumably because of like what had happened in the ancestral state. Like that's it's really cool. And then not the bone, which I mean obviously that'd be like a huge difficulty to regain something like that.
There's a thing in evolution that's called Dollo's law. Are you familiar with this, Balint? You can look it up on Wikipedia if you're not, but it's pretty cool. Like, we don't often have laws in biology, and this isn't really a law, but DOLLO, Dollo's law. It's this idea that, like, when a trait is lost through evolution, it's never going to be evolved in exactly the same way again. Like, you might... kind of like a panda's thumb is a good example, where, like, pandas, they've got this weird extra wrist bone that articulates with their hand. You know about this. But like it's easier to evolve a new structure than to like re-evolve something that's been lost in the past. Maybe a panda's thumb is not a good example because they didn't lose their thumb. They effectively have like 6 digits now.
Yeah.
But like birds' teeth are a good example, where like birds used to have teeth during the Mesozoic era. And then all of the toothed bird lineages died out when the asteroid hit. And then there were certain birds that, like, they kind of needed teeth again, but they didn't evolve proper teeth. They evolved these, like, sharp points sticking out of their beaks. So if you look up another bird... Sorry to make you...
No,
jump
please,
Google
please.
Images. Pelagornithus. P-E-L-A-G-N-O-R... Pelagornithus. Yeah. So find one of the ones with the pseudo teeth.
Wow, this is real
cool?
today?
So No. They went extinct a few million years ago.
Okay, because I saw the image and like, whoa, this looks real.
These are some of the largest flying birds that ever lived. So these are from after the extinction of the non-bird dinosaurs. It's way after the asteroid, when all of the birds with teeth died out. And these guys kind of needed some sort of toothy thing again, but they didn't re-evolve proper teeth in sockets. They just evolved these like sharp points on their beak like that. We call them pseudo teeth, like fake teeth. And they don't get replaced like normal teeth do. They don't have roots or anything.
Because it's
like
part of. It's just like a jagged beak.
Yeah,
right.
It's a jagged edge of their jawbone that gets covered with keratin. Yeah.
So you know what really fascinates me about this is because of the experiments being done on chickens, right, to bring back the toothed dinosaurs.
They're bringing back the actual sockets for the teeth, though. That's the thing. Yeah.
Yeah, they're not adding genes, right? They're just activating them. So it's weird, and evolution acts in weird ways, but like you have the genetic information there to make teeth again.
Yep.
And
for whatever reason, in these critters, that didn't get used.
Yeah, right. Like it's weird. Because this almost seems like it'd be harder.
That, like, even when that information is still there, it's like for whatever reason, they just kind of can't use it. Like whatever, maybe it's like a mutation that would make the embryo non-viable or something, and maybe you need to do that in a laboratory setting in order to make it work. I don't know, but yeah, this is a good example of like Dollo's law, where these birds, their ancestors had teeth at some point, but when they need teeth again, they're not going to re-evolve teeth. That's gone. It's lost.
Yeah.
Or maybe not lost. Maybe the gene is still there, but like they're not going to get it back.
That's what gets me. Pathway. Is that the gene is there, right? Like you have the genetic information. You just have to turn the regulator back on.
And they do this crazy weird detour to evolve these spiky beaks instead.
Yeah. And so like looking at the law that you were telling us about, right? It's like the old form and how to go versus this new thing that happens, which I guess like from a speed perspective, but it's like you still have you have the double information almost, right? Like you're using one path, but you still have this alternative genetically present. It's just this is so cool. This is so freaking cool.
Dollo's law. Yeah,
Wow.
yeah.
Dang. That is absolutely remarkable, this bird. I had no idea this was a thing.
Aren't they neat? Yeah,
That is
yeah,
really
very cool.
cool. Wow. I
Yeah, a friend
just
of mine works on those. He named a new species of it from South Carolina. Yeah.
that oh so they were like United States based too. Do we know anything like diet wise
We've
or
got some from, I think, from Chile.
okay.
And then we've got some from the east coast of the United States and the west coast of the United States. They used to be, I think, cosmopolitan. They used to be pretty much
Okay.
worldwide.
Huh.
But they're seabirds.
Oh,
Picture
cool.
like an albatross, but like 3 times bigger, and it's got those spiky pseudo teeth in its beak. Yeah. Yeah.
Lord Kerbias is wait, they're trying to recreate dinosaurs by reverse evolution. Am I understanding that correct? Danny, do you want to take that one?
Yeah, sort of, kind of. There's a project that my old boss and some of my colleagues are working on called the Dino Chicken Project. And basically, the idea is that they're taking, they're trying to take chicken embryos and then modify the development of those embryos so that the chickens develop these ancestral traits that they're still holding from their dinosaur ancestors. So picture like a chicken, except it's got a long bony tail, and it's got claws on its wings, like fingers, like a velociraptor, and then it's got teeth in its beak, and maybe even like a velociraptor-like snout. So it's still a chicken, but it's got these kind of ancestral traits that they've managed to bring back. That's the idea. That's what they're trying to achieve. Um, and it's turned out to be really, really difficult to do the tail in particular, because lengthening the tail kills the embryo. And apparently it's because there's like an immune response, and it just destroys the immune system when they do that. So that's actually be cool to talk to you about, Balint, in the future.
Yeah, we should do a deep dive together on that. Like, if there's
Yeah,
a new paper
yeah.
or even just like an existing paper that's older, we could like dissect the
Well,
two elements of it.
I want to be able to interview, one of my colleagues from Montana. I think she's still working on it. Dana Rashid. She's got a TED talk about this. But I think she's still hard at work on this project, and that'd be really. She's a really cool person, and that would be really cool to have a conversation with her, and then kind of bring that over here too.
Yeah, absolutely. We had
Yeah,
a first
yeah.
time chat that I think, Danny, if you wouldn't mind taking, how does a
Uh-huh.
reptile become a chicken?
Oh, well, chickens are reptiles. Birds are a kind of reptile. Because here's the thing, and I know this is like not what you probably learned in school. In school, we all learn this like neat, tidy thing where it's like, oh, well, there's fishes, and then a separate group is the amphibians, and then we have the reptiles and mammals and birds, and each of these separate groups. And that's not actually how things work. Like that does not reflect how these organisms evolved or what their history is. Fishes came first, and then amphibians evolved from fishes, so amphibians are a kind of fish. And then from amphibians, you had reptiles and mammals that evolved. And then from reptiles, you have birds that evolved. So birds are a kind of reptile, which are a kind of amphibian, which are a kind of fish, if that makes sense.
I like that explanation a lot because you're right. Like in school, that really is like these almost insular
Yeah.
groups that aren't connected to one another. So like, I think that's why there's always this like hesitation of like reptiles being birds because
Yep.
it's like you're looking at the end product,
Uh-huh.
right? Like here is this crocodile and here is this bird. These two things are different.
Uh-huh.
Versus,
That's actually a really good example, Balint, because both crocodiles and birds, today they're each other's closest living relatives. So a crocodile is way, way, way more closely related to a chickadee or a chicken or a canary than it is to a lizard or a turtle.
which is wild, right? Because by eye, naively,
Yeah.
right? Or just like
Uh-huh.
scales, or like the things
Yeah,
that we
well-
like zoom in on, like untrained eye,
Uh-huh.
like not looking at like structural conservation, but just like
Yep.
a lizard.
And that's
looks
because
a
we're
little-
looking at it in the modern day too, where we don't have those in betweens anymore. If you could look at a dinosaur in between, you'd be like, oh yeah, that makes sense. Bird, crocodile, a dinosaur looks like it's perfectly in between. Since we're missing that intermediate step, it blows people's minds that like chickens are related to crocodiles. But it's because you're missing that missing puzzle piece there.
which is why I think the chicken project that you were talking about, it's the importance of that too. Like, independent if we get it to work or not with the tail, which is really weird that the tail is like a hang up. Like, I would have thought like
I know, right?
the beak
You'd think that'd be the easiest part, but nope.
Yeah.
The teeth are really easy, but the tail breaks everything. Yeah.
Which is inherently interesting, right? Because it's like, why is that a thing?
And it's an immune thing. It's like an immune response.
And so it's like, I think the importance of that study is just to demonstrate, like, creating that missing link between those states and, like, really demonstrating the power of evolution in that study. Like, I think you've shown the TED Talk, right, with your old crew chief, that he was talking about, like, kids want little dinosaurs running around, and that's great because you can make it chicken size, but also the importance of demonstrating, like, that connection between, in terms of evolution, like, showing of how that happened. He said it much more eloquently than I just did, but it was, like, a really powerful statement.
Jack Horner says that he wanted to do this project because he would like to go to a school assembly and then have a dino chicken on a leash and just ask the kids, like, what is this? What? Tell me what it is. It looks like a little velociraptor, but it's a chicken. It's got teeth like a velociraptor, or maybe like a crocodile. More like a crocodile than like a chicken. Chickens don't have teeth. And he wanted to have just like a moment like that where he could just show it to people and let it spark their imagination, get them excited about evolution. So that's really cool. It's just like a science outreach kind of thing. But Dana Rashid, she's the like lead researcher on the project, she's found a potential like medical benefit for this as well, where when you're trying to keep the tail of the embryo chicken long, because the chicken actually starts out with a pretty long tail in the embryo as the chick is growing in the egg.
This
it
is
starts
regular,
out with kind of a long bony
unmodified,
tail.
right?
Yeah. And then a gene kicks on and kind of destroys the tail. It gets those vertebrae to fuse up together and it shortens. And so basically, in order to get it to hatch out with a long tail, they got to find a way to counteract that. Stop that gene, stop that developmental process. But there happens to be a human disease called ankylosing spondylitis. And some people in chat might know about this. But it's a disease where your vertebrae, maybe in your neck, fuse together. So like you can't bend your neck anymore. And apparently it's extremely painful and just like a really nasty disease that there's no cure for it and we don't really know what causes it. But it's about those vertebrae fusing up. So the idea is if we can figure out how to prevent the vertebrae from fusing up in a baby chick's tail, maybe that'll be the key to figuring out ankylosing spondylitis in people and preventing that from happening. It might be like the same exact mechanism right there. So if we figure out how to prevent it in chickens, we can figure out how to prevent it in humans as well.
That would be remarkable, yeah. At least, I guess if you could figure out a test to pre-screen for it too during the embryo development, and then the intersection could be just like you put in like a small molecule that inhibits or activates a gene that allows it to, progress as it should, not how the blockage happens.
The way that Dana puts it is that like this is a terrible disease, and we don't even have a model organism to study this in. We have no model for ankylosing spondylitis. We're in the dark about it, but maybe chickens could be a model for studying this, for studying their vertebral fusion like that. It would be a step in the right direction.
And it's incredible, like this is a serendipitous piece of research, right? Because presumably she didn't go into studying this mechanism in chickens to help a disease in humans, right? But now that could be the thing, which is why basic funding in basic sciences is so important, because it could lead to a cure in something.
Yeah.
And there was a really...
hopefully I'll be able to interview her about that at some point, and that'll be cool.
I'm looking forward to it.
She's on my list.
There was, I think, an important question in the chat about that project. If genes are no longer dominant or active, is activating the gene considered a mutation then? Similar to how they've isolated genes of ball pythons to create different morphs. Let me think my kid. Oh, no, the kitty.
I think, yeah, thinking about it from an evolutionary perspective, I would think of that as a mutation. That's something that natural selection can act upon. Yeah, for sure. A lot of mutations, they're not like in X-Men or something, where like suddenly you have 10 eyes, or you can belch out lava or whatever. Like, mutations don't work that way. They're usually much simpler, much smaller. And, yeah, and it can just be like the way that a gene is expressed can have like huge ramifications. In that TED talk that Dana gave, she talks about like domestic dogs and all of the wild shapes and sizes that we have of dogs, Chihuahuas and Great Danes and Saint Bernards and Whippets and Bulldogs and limitations. And apparently all of those different, like, crazy morphological differences between those dogs are all the result of 3 genes, and presumably how those genes are expressed as well. That's probably a huge part of it. That's why it can just be 3 genes that control all that stuff. Is like you're also changing the expression of those genes, I would imagine.
Yeah, that's. I would also consider it, I guess, as a mutation. Like when you're activating back something, because in the natural state it's inactive, and so either a regulating element you might have to mutate, or the gene body itself. Like some of these genes, like they're totally intact, but maybe there's a stop mutation that occurred. So the gene starts getting turned on, but then you have a premature stop code on, and it just stops it and shuts it down. And so if you revert that, that is, Lord, that would be a mutation then that you're introducing to make it back active. So even though maybe you're restoring the original state, you're still performing a mutagenesis to get it back to that state.
Right, and I think that's an excellent question too, and it kind of reveals a bias or a blind spot for me. Because when I hear mutation, I think like, oh yeah, it's a new gene being created or a gene being destroyed or something. But like usually it's much more subtle than that, and mutations don't just have to be the addition or subtraction of a gene. Like those are probably pretty rare, actually. Those kinds of mutations. Compared to like just how those genes are expressed.
Yeah, I mean usually it's like a regulatory element instead of it being a gene duplication, which then gets a mutation and becomes its own thing, right? Like it's usually like much more internal baby steps that's happening. And silly question for you, Dan. We were talking about species last night. Of if the Borg is a species and is it alive? Like we were, but that sparks to me the question of, if we have this chicken dinosaur,
will we be assimilated?
Well, you never know, right? I've seen Jurassic Park, but is that a new species? Because all you've done is change the regulation of the gene.
Well, that's the thing too, is that originally, like when you watch the TED Talks with Jack and Dana, they talk about how it's not actually changing the genes, is just turning a gene on or turning a gene off. This is before CRISPR. Like they started this like 15 years ago. Maybe longer. CRISPR is a thing now, and that you can actually alter the genetic code with that, and that is something that they're looking into now, as I understand it. So you are actually changing the genes as well. But yeah, the question does become, when is it a new species? Like, is a Great Dane a different species from a Chihuahua or from a wolf? And there's a lot of debate about this kind of thing. I think most biologists would be like, no, it is the same species, it's just been artificially selected. When I think of species, I think of them being natural, like they've occurred via natural selection. You've had some sort of a speciation event that's caused a population to split, no longer spread genes back to the parent population. And yeah. So would it be a new species? I guess if it were around for long enough, at some point you could call it a new species. And nobody would argue with you. But like, at what point? I don't know. It becomes kind of arbitrary.
Yeah, and I guess the ethical side of things too, of like, if you're bringing a new animal to life, should you bring multiple and then like establish a breeding colony? Like, it starts like, And I'm not saying we shouldn't do it. I'm not at all against the chicken reason.
Yeah.
I think it's
But I mean, we've
super
done
cool.
that. You know, like, well, feral cats and dogs. Those are, you know, they've been released into the wild, and shoot, it's probably the same thing with bees too, right? Where like domestic bees can push out,
pigs, hogs,
native bee species.
Like
What's that?
hogs, right? Like loose
Yeah,
pigs that
feral
cause
hogs. Oh,
huge
man.
destruction in the environment.
Uh-huh.
I guess
isn't
it's the
that
idea.
playing
It's like,
God, even though it's done like accidentally or carelessly.
yeah,
Like, yeah.
and maybe it's because
Yeah.
one is a little bit more artificial. Like one is like we're doing this intentionally with genetic changes versus one is like we're just selecting for physical. It's like I guess is the argument like I'm eating a tomato is a GMO if I've injected DNA versus this tomato isn't because I've selected for 100 generations of a large tomato.
I mean, all cultivated plants are done the old-fashioned way, you know?
Exactly.
A lot more messy.
Raiders, welcome the heck in cricket. Cricket, there is a cricket infestation. How was the stream, Cricket? Welcome the heck in. Guys, the lovely Queen Cricket is in the house. How was the stream, madame? I want to know all the details. Acid Muck, hello. Giraffe Killer, hello. Cookie, welcome in. Cookie Jar Pottery, Boomin' Resources, Karaoke Twitch, Yo, welcome on in. Cricket, how was your art stream today? I saw you were doing a beautiful homage to one of our friends by the name of Giraffe Killer. Welcome on in, ma'am. For those of you who don't know, my name is Balint, 1/3 of SciAnts streams. The other 2/3 are my lovely wife, Lita, and our daughter, baby Alona. We're research scientists, and we do interactive science streams here on Twitch most days of the week with microscopy, art, sci-fi, science news of the week, deep dive scientific topics, games, 3D printing, IRL streams, model building, and more. And tonight we're having our usual weekly crossover stream with Professor Danny Anduza of Paleontologizing. He is here with us. We're talking fossil science. We're talking genetics. We were looking at aging and the epigenetic clock. We were also doing orbital size, so like the size within the bone structure of a dinosaur, and looking at like how that might correspond to eyes and eye size. Danny's chair is also here. That's true. Real men grow beards. We're doing like some Q&A between them. Guys, please go follow our friend Queen Cricket. We just actually gave her the Fancy Pants shout out, so it's on a cooldown. But she is a variety streamer. She does art. She does games. She's got a beautiful puppers. And she, just to illustrate for those wondering, we met her on a raid over 2 years ago. 10 minutes after meeting her, my friend and I, who got raided in, subbed to her for 6 months in advance. That is, nice. Yeah, she is a gem of a human. She's extremely kind. She's also a Pantene hair model. She's on billboards in Colorado. Please go follow the lovely Cricket. Ma'am, thank you very much for the raid. And she's also one of our mods in order to prepare for this front page shenanigansery that we're going to be having. So welcome the heck in, y'all. Cricket, if you want to share the art you were doing, we'll show it once Danny has signed off for the evening. Again, y'all, welcome on in. We were just talking about eye size, vision, and then we were talking about this genetic project of they're trying to reverse engineer a dinosaur from a chicken. Essentially, right, is the crux of it. They're able to get the chicken to have teeth and a beak, like more dinosaur-like. They just can't get the tail to work, which is apparently due to an immune response, which is kind of crazy.
Yeah. And sorry I had to run away for a second there. My 3D printer was just about to run out of filament, so I'm glad I was able to catch it and put a new spool on. So
no, absolutely, because you were saying last night it ran out and it wasn't. Yeah, absolutely, yeah. What are you printing, Danny? Can we know?
Yeah, I'm printing a little model of an Edaphosaurus. Edaphosaurus it's not a dinosaur. It's actually it's from the mammal branch of the Tree of Life, so it's closely related to our ancestors. It looks a lot like Dimetrodon, except it was a plant eater. It's got that big sail on its back. From the Permian period, like about 50 million years before the first dinosaurs. Something like that, maybe 30 million years.
And so it's Dimetrodons are not dinosaurs?
That's correct.
Yeah,
Dimetrodon is not a dinosaur. Edaphosaurus, also not a dinosaur.
So that and plesiosaur have hit me hard, Danny, because I had, as a kid, you showed it on stream, this book. It was like a hand-drawn book of dinosaurs from like the 80s. and one of the like that the
do you
sale.
remember what color the cover was? Because I can grab it.
Browns with like maybe triceratops on it with greens.
Maybe triceratops with greens. Yeah.
It was. I remember you showed it on stream, and I was like, "Oh my god, what a throwback to my childhood!" That was my favorite book as a kid.
Yeah. Shoot. Let me. I think I know. It's one of 4. I think. Were they like storybooks?
I think like it said like a story. This plesiosaur came out of the water, and like how it like encountered these different dinosaurs, and this core memory of childhood unlocked with that book.
Yeah. Here we go. It's gonna be one of these.
That first one.
It's
the top one. It's the top one.
This one right here?
Yep, that's it.
The Colossal Book of Dinosaurs. Yeah, this is there's 4 books in this series, and I only had one of them when I was a kid. I had the Mammoth Book of Dinosaurs. Mammoth like large, not mammoth like ancient elephant. But yeah, let me see if I can find the one with the plesiosaur.
Yeah, that was the cover of it, and I don't think we have it here. It's back home in Georgia. Happy Nightmares! Welcome on in, Raiders! And hello, Darth Banana as well. I don't know if it was like a different edition as well, but it had the plesiosaur in it and the Dimetrodon, and that was told to me as like this is a dinosaur, and it's like it just ever since your stream I'm like, oh no, it's not a dinosaur.
Here it is. Yeah, this has got Dimetrodon and Plesiosaurus.
Oh, okay, maybe it was an alternate version. Raiders, welcome on in. Happy Nightmares. How was your stream? Tell us all the details. How is Scarab of Ra? Sounds Egyptian. And Cricket, thank you for the gift sub to Darth Banana. Thank you, Cricket. Welcome to Heck In, Raiders. My name is Balint. Hi, Outlaw. And I'm 1/3 of SciAnts streams. The other 2/3 are my wife, Lita, daughter, baby, Alona. And today is our crossover day. On Wednesday, we bring on Professor Danny Anduza of Paleontologizing. And we're talking fossil science, dinosaurs, genetics, and more. Welcome to Heck In, everybody. It's great to have you all here. Happy, thank you very much for the raid. I hope your stream went lovely. Cricket, thank you for the gifts up to Darth Banana. And Jonesy, thank you for the follow as well. Welcome on in, everybody. But yeah, so Danny, that's
right
it. That's the picture. Yep.
And I think, we have a Dilophosaurus right here too. So Dimetrodon is right here, and there is Edaphosaurus, which is a plant-eating pelycosaur. It's got a smaller head, it's got more blunt teeth, different shaped sail. That's what I'm currently 3D printing. Is like a little model of Edaphosaurus. It's gonna be about this long, about this tall. Excited about it. Yeah, there's a sculptor online who made it, who's excellent.
I remember that picture that you just showed too. Like Hanny too. Like that picture, because as a kid I didn't I think when I got that book I didn't speak English yet. It was just Hungarian, right? And so I was looking at the pictures and be like, I wonder if these are 2 different species because they look different. And it was I used that book so much that the spine had like almost wasted away. Like it's a different edition from you have. It was like a brown cover, and it just had kind of like died away because I read it so many times even before I can speak English. I was just always looking at the pictures, and I would draw them, and it's just I remember one of the very first streams I came into of yours, I asked about plesiosaur, and you're like, actually that's not a dinosaur. I was like, no, the childhood.
Like, and I had just recently gotten all 4 of these books again. I had 2 of them as a kid, and then I was right when I started streaming. I was teaching full time over Zoom, and I got these books so that I could read the stories to my students during our Zoom classes. And then one of them was this. I wanted to highlight the plesiosaur right there, and how at the time we thought that plesiosaurs laid their eggs on land like this.
Mm-hmm.
And then that's kind of a plot point in this story, is like, oh no, there's these
theropod I remember that
chasing the mother plesiosaur.
It's like the next photo, or like the next few pages, there's one where her neck is injured.
That's, I think, a different story.
Okay, I just remember like that was like one. I was like, oh no, the plesiosaur got hurt.
There's another story where she gets eaten by a Dilophosaurus. That's in the Dilophosaurus one.
Oh,
Let me find that for
that's
you, 'cause
yep, that must be
it's
it.
a really, really cool. That's one of my favorite illustrations. Like I should scan that, and print it, and put it in one of my frames.
It was
That's the one that I think I had when I was a kid.
in preschool, Danny. When we came to the U.S., I didn't speak a lick of English, and they put me into preschool, right? So you can start learning. First day I came home, my dad was like, "What did you learn?" And I told him I learned the word schlafen, because they tried to get me to take a nap, so they were speaking German, not Hungarian, but neither here nor there. We early on built paper mache eggs of dinosaur eggs, and when you went outside to play, then the teachers cracked it open and put a toy dinosaur in, and my quote toy dinosaur was a plesiosaur, and it was this little character, and that's why I was like, I love plesiosaurs. So that's why, like, ever since a little kid. And it changed.
When I was a kid,
yeah,
for a good while, plesiosaur was my favorite kind of extinct creature as well. I knew they weren't dinosaurs back then, but I could read these books in English, so I was at an advantage there. But yeah, there's a plesiosaur coming up onto land.
That's it.
There's a very hungry-looking Dilophosaurus, and then it doesn't go super well for the poor plesiosaur there.
Oh man, that's it.
Beautiful illustration. Like, the artist really put his all into this one.
Yeah,
looks a lot better than the other ones. Like, that one not quite as So the funny thing is, like, it's almost a trope in like older dinosaur books. Like, the mother plesiosaur comes up onto land, and then these hungry theropods just tear her apart and eat her before she can even lay her eggs. Nowadays, we know that they didn't lay eggs. Plesiosaurs actually gave birth to live young in the water. So that never would have taken place. They would have been safe from those predators because they don't have to come up onto the beach. And the reason that we know that is we have plesiosaurs with embryos inside, and the embryo is, like, huge. It's like giving birth to a baby elephant or something. And it's, like, way too big for it to have been cannibalism, like she's eating this, and also all the bones are there. Like, that's very clearly an embryo, which shows that, despite being reptiles, these animals, A, were warm-blooded, and B, gave birth to live young in the water, which is super cool.
Yeah, and it shows, I guess, the magic of change and evolution, too, right, of how these animals came to be. It's funny, Chad's saying, too, like, my favorite was Velociraptor growing up due to Jurassic Park, and then it was heartbroken when I found out their size was a lie.
Well, in Kuroki Twitch says, my favorite is the Deinonychus. Deinonychus is the Velociraptor from Jurassic Park. Jurassic Park's Velociraptor is actually Deinonychus, which actually was bigger than actual Velociraptor. It's a whole long story. Follow my channel if you want to hear about this, because I can tell you all about it.
It belongs in a museum.
There is the shout out. The fancy one, y'all, is still on cooldown. Of course, as Danny, you don't even have to be here. We shout you out, sir. That's how much we appreciate.
And I don't know what a fancy shout out is. I don't know how to do that.
Oh, so that's, you do / and you type shout out, and then a space followed by the streamer's name. And so when you do that, in chat appears a box with the streamer's name with a heart in it, so it's really easy to click. And so that's when it's the easy way to direct people towards someone to go follow.
Gotcha. Okay.
And so that's...
Thank you for teaching me that. I might have to use that in the future.
Yeah, it's like...
do some SciAnts stream shoutouts.
Well, so whenever, when our raiders come in, I always that's what we hit, and then, we got friends coming in, but also, like, when we're promoting SciAnts here, it's like, 100%, like, it's, you're always getting hit, so... That's why it shows up, y'all.
I see them in my activity feed, for sure, yeah.
Dang it, Balint, what are you up to again? I'm sorry, I'm excited.
SciAnts Streams gave you a shout-out to 499 viewers. What?
Don't worry, it'll be 10K this weekend, allegedly. Assuming we have the right front page feature to advocate for SciAnts, but... And there's a funny... I think Real Men Grow Beard said that my dinosaur egg of plesiosaur was wrong for multiple reasons.
There you go. Yeah, they didn't actually lay eggs.
Yeah, it's amazing what we can learn from the fossils. And, oh my goodness, Danny, I've kept you over.
Oh, it's fine. It's fine. We can continue with this paper.
Okay,
Yeah.
I am so sorry. I'm like, we got
No
so
worries.
rabbit hole and
Yeah.
excited.
If I didn't notice, it's not a problem.
Okay, awesome.
Yeah.
Yeah, so where else do we want to chat about in this paper? So we talked about the orbit length and how that corresponds to, there
Yeah.
really wasn't a lot of variance, so you felt like it was more of a confirmation paper rather than anything else?
I would say so, yeah. Yeah, so they are introducing original data here. It's not like it's a review paper, but there's nothing super surprising about it. If you scroll down, there's another really cool figure. Yeah, if you open up the actual paper, or you could just open it up there. There's a neat graph with like all of these. There we go, that one. Yeah. So this is a bunch of different groups of Archosauromorph, including a bunch of dinosaur groups, and also crocodilians and stuff like that.
What? So what? Sorry, what does it mean? The Archosaur?
Yeah. So Archosaurs are the group of animals that include dinosaurs, which includes birds, and also crocodilians. And Archosauromorphs are their close relatives too. So it's like a bigger clade. Archosauromorphs are like archosaurs and their allies.
Gotcha.
Yeah. So yeah, this kind of shows just like how early they diverged. So like in the very center of that spiral is like the origin point, and then you've got these different clades that evolve off of that.
So this is like a unique way for like Chad to look at a phylogenetic tree. Like usually if you're looking at like the horizontal lines, they're going in like a line versus like this more holistic global view. Like I think this is what like a multi-dimensional one that you're supposed to get information from.
Sort of. It also incorporates time. So like the ones closer to the center are the ones that evolve first.
Mm-hmm.
And then this one actually, I guess, doesn't show when they went extinct, because they're all there on the perimeter.
Right. And so if it wasn't, it would be like it would stop early, right?
Exactly. Yeah. But with this, I guess they did it like a circle like this, so you could just fit a ton of branches on there. If it were the typical like diagonal line with the branches coming off, you'd not be able to fit them all. So like this is a nice way to fit all those different lineages on there.
Yeah, I think it's a really nicely done, and it's like again, it's sometimes hard to see of like where the split points are in terms of like relation to other animals.
Yeah.
Like, because it's just like the res is like just so fine and like what you can fit in a figure, but like a global
that should
view,
be like a poster that's like 3 feet wide.
Yeah. Oh yeah, no, this would be great for a paper, like a poster, like a poster view of it would be super cool. And so it's when this orbit size they're comparing, like it's pretty impressive of how many they looked at. Like I know you said it's kind of like reaffirming the existing data, but it's remarkable of how
it was very comprehensive. Like they really put a lot of work into this. I think that's why it's so cool.
Yeah.
And it's interesting that like orbit size is like, I wouldn't say it's uniform in dinosaurs, but it doesn't change that much like it does in mammals. Like in mammals, you've got really big mammals that have small eyes, and then you've got small mammals that have big eyes. And here it's like, dinosaurs are fairly conservative with their eyeball size, or with their orbit size at least.
Do we know why?
Yeah, and it was interesting too that there were a couple of weird things that they said in the paper where it's like tyrannosaurs have got proportionally smaller eyes than other dinosaurs, which is crazy because as far as we know, the dinosaur with the very biggest eyes in absolute terms is T-Rex. And so it has proportionally small eyes, but it has, as far as we know, the largest eyes of any dinosaur. Eyes like the size of oranges, maybe. Like really big.
Is that based on the orbital or that secondary bone structure? I forget that we were talking about this.
I don't know if we have the sclerotic ossicles for any tyrannosaurs. We might, but it's based on the size of the orbit.
Gotcha.
Yeah, the actual bony eye socket.
So it's a good enough proxy where you're convinced that that's gross size, like where like we can say it's like the biggest eye, even if it's proportionally not.
Yeah.
Okay.
Yeah. So it's funny. Like, at what point, how big does an eye actually have to be? If you're an animal the size of a T-Rex, an adult T-Rex, or an adult blue whale, It's like, are there diminishing returns after a while? Just like making your eyes bigger and bigger and bigger? Or is there a size where it's just good enough and you're like, it wouldn't help to be any larger? And I kind of suspect that might be the case.
Or I guess it depends on what the goal is almost, right? Like, why is the animal, what is it using its vision for? Like you were saying, like maybe the T-Rex's vision was good enough and then it used olfactory cues even to detect prey.
We do know that the T-Rex had an incredible sense of smell. Like, its olfactory bulbs in its brain are enormous, like freakishly huge. But it also had really, really excellent vision, we think. So and probably pretty decent hearing.
In dreams, one is not tethered by earthly limitations. What does that mean? Come.
They just didn't need it that much. But, yeah. Anyway.
Yeah, I wonder, it'd be interesting to note if there's a transitional species missing in Tyrannosaurus where they had even bigger eyes, and you can even see like the trade-off of like the like the olfactory systems like enlarging while the other eyes are shrinking. And
that's a great question. Holy cow. Where like we do, none of this stuff is published yet, but we do have a general sense that the arms on T-Rex got smaller over time.
Yeah.
Throughout like the Hell Creek Formation, T-Rex from the bottom, which are like 67 or 68 million years old, they've got bigger arms than the ones toward the top, about 66 million years old. So over that 1 or 2 million years, the arms on adult T-Rex, they seem to just be trending smaller and smaller over time. And it'd be really cool to be able to look at their brains and figure that out, see if there's a trend toward larger olfactory bulbs or larger or smaller eyes or something like that. I guess you could look at that in the brain too. You could look at the size of the optic nerve and try and figure out, is that growing or shrinking?
Yeah.
Is that trending larger or smaller over evolutionary time? But we don't have enough specimens. We've got like 50 T-Rex specimens that have ever been found, and that is way more than most dinosaurs. Most dinosaurs, we only have one specimen. So that's a pretty excellent sample size for T-Rex, but like, if you only had 50 Drosophila melanogaster, that'd be nothing.
It really puts it in perspective, because we've talked about, like you've said, like even now, like we're pretty good on the T-Rex numbers in terms of comparison to other dinos, but it's just really interesting to hear like where you're limited on for certain data that you're trying to get out, right? Like you said, like new species, sometimes one dinosaur is all we have, but then this other point, it's like, well, we actually need more than that. So it's interesting to see that divide and where it's drawn.
You also have to introduce time into that as well too, because T-Rex is around for like maybe 2 million years, maybe a little longer if the one from New Mexico is ancestral to T-Rex. But so we've got maybe 50 Tyrannosaurus specimens, but those are all from different times. We don't have like a bone bed of T-Rex where we've got 20 individuals that all died in the same time in the same place. So you can actually compare individual variation and, maybe male-female differences or something like. We don't have anything like that. Each one of these ones is from a different time horizon. And so it also makes it really tricky,
It almost makes them still individual samples versus that 50.
Yes, exactly. And for some dinosaurs, we have like 30 of them that all died in the same place in the same time. They're part of a population that was all coeval. They all lived together.
It's like Triceratops.
That's really useful. Yeah, yes. Well, we don't have that for Triceratops yet, but for other dinosaurs like Centrosaurus, we do.
Okay. So I thought that misremembering that they're like really, there's a lot of Triceratops fossils, right, that have been discovered, and it's just.
But it's like T-Rex, where they're all from different times and different places. Yeah.
Okay. Gotcha.
I don't know if we've ever found more than like 2 Triceratops in the same spot. I don't think we have a single like Triceratops bone bed that's. I'm sure they exist, but some of them have been dug up by commercial groups, and so they're lost to science.
Yep.
Yeah.
Okay, gotcha.
But yeah.
That's.
So yeah.
From an experimental perspective, it's a nightmare, but it's really cool to hear about like these considerations of like for certain things this is good enough, and for others it's like we actually need a totally different way of interpreting the data and then collecting the data as well for it. It's really, really cool.
Yeah, and I mean, as a geneticist, you're looking at this and going like, oh, this is a nightmare sample size-wise. Like, what can you even do? But I don't know, from a paleontologist perspective, we're so lucky to have anything at all. These animals lived tens of millions of years ago. Like, it's a miracle that we can even know that they existed, let alone be able to actually understand their biology in any meaningful sense. Like, that is so cool. And that's what I get excited about.
I think it's remarkable of how much we know today, given like all I've learned in like our chats as well, and like what it would take to make the conclusion to modern genetics versus what's possible to do here.
Yep.
It is remarkable of how much we know. Tommy, hi, welcome in. Tommy, very late. No, Tommy, you're always on time. Tommy Plotkus, welcome on in. So yeah, that's it's a really cool paper. I guess you were saying you were kind of like, yeah, this makes sense, and it's just kind of almost a drabish feel. I was blown away by the volume of data, and even
that's the cool thing about it.
Yeah. Even though it's like
they're able to look at this like big broad group of animals and like track this one anatomical measurement across all of them and like see a pattern where it's like, yeah, the ratio is generally the same for most of these creatures.
Yeah.
Like, they kind of stay within these bounds for orbit size compared to skull length. And it does kind of imply, I guess a take-home message from this would be that dinosaurs had pretty good eyes, and they relied on their eyesight pretty well, and they would have been pretty visual animals, which makes a lot of sense when we consider that a lot of them evolved these crazy display features, horns and frills and crests and bony lumps, all kinds of stuff like that. We would expect them to be very visual animals if those things were indeed for display, which it seems like they were.
And I was thinking about too, like the preserved skin that we found that has color, the rarities, right? And how you've talked about on the stream that it's like possibly sexual selection acting on too, and it wouldn't make sense to have that, but then bad vision.
Yeah, exactly. Yeah, it's like where most mammals today, like what color are most mammals? They're like brown or gray or brownish gray, like because mammals, for the most part, can't see in color. Dinosaurs would have been totally different. So like all of these illustrations that you see of dinosaurs or dinosaurs in movies were like, oh, they're green or they're brown or they're gray. That's probably completely wrong. Dinosaurs probably would have been super flamboyant in their coloration, like a lot of modern birds are. And
it's interesting to wonder too if that would be sex specific then too during the time of the dinosaurs. Like, would the females be the more like if you saw these greens and browns, is that primarily if you had to pull in that representation, that might be the females, and then the flamboyant ones would be the males because of sexual selection acting as well,
or the reverse? Because like we were talking about with paleonath birds, those like primitive birds. With some of those, the females are the more brightly colored ones, because the male needs to be camouflaged to sit on the nest. Because the females will come breed with the male, and she'll lay her eggs in his nest, and then he's like single dad from then on out. And he's got all these different females depositing their eggs there, and he's got to be more camouflaged to sit on the nest and guard the eggs. So the females are more brightly colored than the males.
So who did the brood care?
Too.
Like, right, who did the brood? Like, it's it's so cool to think about, and like all these possibilities come in play, and it's like you said, more like almost you need to find like a nesting site with enough of a replicate number to be able to identify like sex differences and like what the eggs are there, or if it's live young like the plesiosaur or anything else in between. And it's, I don't know, I think it would be really exciting to be in the field of the possibility of discovering something like that, even though it's rare. Like you could be like the throwback to the beginning of the stream, the holy grail of finding like dinosaur science of that. That's really amazing.
There's so many grails in dinosaur science, and you don't only have to drink out of one. You won't turn into skeleton yourself. There's so many different, like, sometimes one specimen can reshape the way that we think about an entire group of fossil organisms. Because in many cases we know so little about them that, like, just one specimen can be, can kind of change everything. And that's super exciting and super cool.
Yeah. Or like an intermediate species or a site or anything like that. Yeah.
Yep. Yeah. A single experiment, even if it's a natural experiment, like just finding a new fossil, can have a huge impact. And that's, I think, one of the most exciting things about this field.
In dreams,
or I
one
guess
is
even
not tethered by earthly
Womp Womp
limitations.
sleep well.
What does that mean?
In genetics, CRISPR. Like, a one-off experiment has it's a field-changing, a multi-field changing discovery.
Oh yeah, shoot! Like you were talking about CRISPR as like a new thing has changed. Yeah, absolutely. Holy cow! Groundbreaking.
Yeah.
Earth-shaking. Yeah.
I mean, they fast-tracked the Nobel for it.
Did they really?
Oh yeah, it was usually like 20 years, right? Like the circadian rhythm guys who discovered it in the 80s got it in like 2016, 17 for the circadian rhythm, and then the people who published on CRISPR, I think the first paper was 2013, got it 2020 because of how groundbreaking it is. Yeah, and so little things or something that seems like little things can have a huge effect.
Very cool. Yeah. Well,
So,
I should probably think about making myself some dinner here pretty soon.
Sounds so. Shall we call it here then? We only got through one paper each of us. I think the T-Rex paper and the we'll have to wait another week. But I would like to touch on that T-Rex paper for next week.
That'd be cool. Yeah. I guess unless anything super cool and interesting comes out, then we'll do that.
Cool.
I don't know if it'll get usurped. It might, but if it doesn't, that's going to be super awesome.
If it does, it does, right? So, chat, the way we've been doing it is Danny and I email each other 2 papers that we read and kind of familiarize ourselves with, and I like the last 3 weeks now we've only gotten through one of each. I think it's just because we've rabbit holed and it's just been like really good discussions about the sciences behind them, and I mean I'd rather do that than just like breeze through papers.
Sorry, there's a mosquito in my office, and I might have to deal with that in a little bit.
Hopefully,
I see a good question there from Glued with Gold.
Yeah.
Can understanding dinosaurs lead to understanding odd animals around today? For example, the platypus being a mammal that lays eggs. Not dinosaurs in particular, but fossil mammals. It turns out that like during the age of dinosaurs, when our mammal ancestors were running around, the majority of mammals back then laid eggs. That used to be the normal thing for mammals to do. And then when the asteroid hit and wiped out the dinosaurs, except for birds, it wiped out all of the mammals except for a few, including our ancestors. And it wiped out all of the egg-laying mammals except for 2 lineages, the platypus and the echidna. But egg-laying used to be the norm for mammals. But all of the egg layers, except for those 2, died out. And I guess only in Australia did those survive.
Yeah.
Like on the opposite side of the world from the asteroid. So maybe that was a safe haven for them there. Yeah.
Nice. And Punk with band in the band, first time chatter. Thank you for the 5 bits. Appreciate that.
Very nice.
We'll do final question, Danny, from Tommy. Did multi-tuberculates?
You just call them multis.
Multis lay eggs.
Yeah, I didn't know this either, and I asked this question this summer to Fisher, who's a guy on my crew who's a mammal guy, and he's like, yeah, they probably laid eggs. Multis probably laid eggs. Multi-tuberculates were these little, almost rodent-like mammals.
Where's my
They used to be the most common mammal everywhere during the Cretaceous period. And they had these cool little kind of like incisor teeth, and they had these weird premolars that are almost like shears. And they made it through the extinction events 66 million years ago. They survived the asteroid, and then they just decide to go extinct later on for some reason. Like, almost on a whim. They're like, yeah, we're just going to die out at the end of the Eocene after surviving the apocalypse. It's like, yeah, and I don't know why that happened, but yeah. But yeah, they probably laid eggs. Yeah.
That's interesting that we don't know. That's kind of those mystery outstanding questions like, I wonder, why did they go down? What was the selection pressure? What did they lose? Was it the eggs? Was it the food? Was it temperature? Was it something totally different?
It could be that the climate was drying out at that time, because I think it was like South America and Antarctica start to break apart, and then you can have ocean currents going in between, and that cooled the Earth, and the ice forms in Antarctica.
Grow the fuck up. You're not children anymore. I didn't mind explaining photosynthesis to you when you were 12, but you're adults now, and this is an actual crisis. Got it?
Bill Nye is very angry. Awesome. Danny, thank you so very much for coming on. As always,
it's been a joy as always, Balint.
Yeah, they're a highlight of my week. What is coming up on Paleontologizing this week in chat? There is the fancy shout out.
Oh, there's a moth in here too now.
Oh no,
it's an insect takeover, Balint.
No, I didn't send them. I promise.
Let's see. Tomorrow, I think I'm going to be talking about. Let me check. I think we might be talking about Australian dinosaurs tomorrow.
Oh, cool. There you go. Dame Karen, you heard that. The Australian dinosaurs tomorrow.
Let's see. Is that tomorrow or is that the day after? Yeah, Thursday the 25th. Australian dinosaurs for Australia's National Day.
Nice.
Yeah, and then we're talking about Mongolian dinosaurs the day after that, on Friday.
Cool.
For Roy Chapman Andrews' birthday. That's going to be a fun one.
And then tomorrow is also Thursday Burbs Day, right? So if people join
Thursday,
your Discord,
Thursday, yes, indeed,
they can post photos of any new birds. And so, chat, we just gave Danny the fancy shout out. You saw the heart at the top of the chat. Please go follow him. He's also 9 Partner Plus points away from hitting Partner Plus. That's just like either 9 tier 1s or a tier 3 and 3 tier 1s. Just a couple of more people to help him, and then he'll get that higher threshold to bring science even easier and bigger and better to Twitch. And Danny, thank you for everything you do. I mean, so the rest of us can be here doing what we do.
Yeah, I really appreciate your support, and I'm really excited for you on Saturday. Holy cow. The front of the front page is going to be a huge deal. I hope you get 100,000 viewers.
Fingers crossed.
Yeah, awesome. I'm going to have to tune in then. I'm excited. I'm teaching that day, but I'll come home and I'll make sure I check it out.
Appreciate you, Danny. Thank you again so very much.
Yeah. Have a great evening. Say hi to Lita and Alona and the cats.
Yes, sir.
I'll catch you later, Balint.
Thank you, Danny. Bye.
Take care. Bye-bye.
Alrighty, y'all. Big thank you to Danny for being with us as always. That is our Wednesday crossover stream event. We will... Yeah, hi, Tommy! In theory, we should get you VIP slots too, Tommy. Tommy, allegedly. That was a blast. Y'all, there were so many rabbit holes we talked about tonight. But they were so much fun to chat about. I hope y'all check out the VOD, because I hope y'all will see about how Danny and I are both just getting so excited chatting science, and it's just like fields that we're naive to, you know, are like we're both learning about and like coming up with new experiments and ideas, and that's the fun part of science, is like this communication between